Blazor WebAssembly is a single-page app framework for building interactive client-side web apps with .NET. It uses open web standards without plugins or recompiling code into other languages. This course will teach you how to use Blazor WebAssembly and Web API on .NET 6. You will learn step-by-step how to build a shopping cart application. This course also provides a guide on how to integrate a payment gateway into your Blazor WebAssembly component, so that a user is able to pay for products through your application using a debit or credit card or even a PayPal account. Gavin Lawn teaches this course. Gavin is a senior software engineer with over 20 years of experience. I encourage you to leave a comment with the most interesting thing you learn for the benefit of other campers who are watching this course.
Please join me as we build a very basic shopping cart application using Blazor WebAssembly. A few of the significant technologies we'll use for building our application are as follows. The latest version of Visual Studio, which is Visual Studio 2022, and we'll use the Community Edition for Windows. .NET 6, which is at the time of creating this video the latest version of .NET. It was released in November of 2021. SQL Server 2019. Blazor WebAssembly. We'll use Bootstrap version 5 for layout and styling purposes. We'll build a RESTful MVC Web API project for handling database-related functionality and returning relevant data from the server to our client-side Blazor application. All technologies used for the development of this application can be downloaded free of charge. Please see below in the description the locations of where you are able to download the relevant technologies for free. We are going to integrate a payment gateway powered by PayPal into our application, so that a user can use their PayPal account or a valid debit or credit card to pay for the items that are purchased through our online shopping cart application. Blazor is a relatively new feature of ASP.NET. It offers two hosting models, a server-side hosting model and a client-side hosting model. We are going to use the client-side hosting model for the development of our shopping cart application. The significance of this hosting model is that the C# code runs directly within our browsers. What makes this possible is a technology named WebAssembly. In recent years, the creation of SPA applications or single-page applications have become very popular as web solutions. Up until fairly recently, JavaScript frameworks like Angular or React have been the available choices for the creation of SPA applications. With Blazor, we are now able to create our single-page applications using C#. We don't necessarily need to depend on JavaScript for the creation of our interactive UI code. We can create this code using C#. In this application, however, the payment gateway provided by PayPal is coded in JavaScript. So we will use Blazor's interoperability functionality with JavaScript to interact with the relevant JavaScript PayPal code. So let's get started. Let's create our Blazor solution. Let's fire up Visual Studio 2022. Select Create New Project. Let's choose the appropriate project template. Blazor WebAssembly app. Let's name our solution Shop Online Solution. Let's name the Blazor project shoponline.web. Great. Let's add a new project to our solution where we'll create our RESTful Web API functionality. So let's ensure that we choose the correct project template. Let's name our project shoponline.api. Notice that for the authentication type, we are choosing none. We are not going to implement membership functionality, which of course includes login and registration functionality. We'll focus purely on the shopping cart functionality. We want to run our application on the latest version of .NET, .NET 6. Note that we have enabled Open API support. By doing this, the Swashbuckle NuGet package will be automatically installed, and the appropriate Swagger middleware will be automatically configured appropriately within our project. One of the advantages of this is when we run our Web API project interactively, we'll be able to test our Web API code through our browsers even before we have developed any front-end code. So a basic UI will automatically be created for this purpose for us. When we run our application interactively, we'll be able to test each of our action methods through the relevant automatically created web-based UI. Note that you can also use a tool like Postman to test your Web API functionality. I won't be using Postman during the development of this application. We are going to build our database using code-first migrations and Entity Framework Core. Migrations allow us to evolve our database without losing data or database objects. So by using plain old C# classes, we can build the database entities that we wish to include within our shopping cart application. Once we have created relevant entity-related C# classes, we'll look at an entity relationship diagram that represents our shopping cart application's database design. Let's add a folder named Entities to our project. This is where the classes that will represent our database entities will reside. So let's create a class named Cart to represent the cart entity. So let's add two public properties to this class: ID as integer and user ID as integer. Let's add a new class named CartItem. This entity represents an item that has been added to the user's shopping cart. So let's add an integer property named ID. Let's add an integer property named CartID. This property represents a foreign key field and is used to join the cart entity to the CartItem entity. So the cart entity has a one-to-many relationship with the cart item entity. This denotes that many cart items can be included within one particular shopping cart. Let's include an integer property named product ID. Lastly, let's include an integer property named QTY, representing the quantity or number of a particular product that may be included within a particular shopping cart. Let's create a new class representing the product entity. The product entity will have a one-to-many relationship with the cart item entity. This denotes that a product can be included many times across many different shopping carts. Let's add an integer property named ID. Let's add a string property named name. Let's add a string property named description. Let's add a string property named image URL. Let's create a property of type decimal named price. Let's create a property of type integer named QTY. Lastly, let's add a property of type integer named category ID. The category ID property represents a foreign key from the product category entity, the code for which we are about to implement. So let's create a class named Product Category. This entity has a one-to-many relationship with the product entity. Let's add a public property named ID. Note that when a property is named ID, by convention, Entity Framework Core will designate the ID property as representative of the relevant entity's primary key. Let's add a property of type string and name this property name. And lastly, let's create a class to represent our user entity, which of course represents a user of our application. Note that I've included this entity as a temporary substitute for a membership facility, like for example, Microsoft Identity, so that we can focus on the shopping cart workflows and not be distracted by the membership functionality. So let's add an integer property named ID. Let's add a string property named username. So if we look at this entity relationship diagram, we can see the relationships between our entities. The cart entity has a one-to-many relationship with the cart item entity. The product entity has a one-to-many relationship with the cart item entity. The product category entity has a one-to-many relationship with the product entity. The user entity has a one-to-one relationship with the cart entity. So this basically means each user can only have one shopping cart within our application. If you look at the SQL Server Management Studio that is installed on my local machine, you can see that I've already generated a database through EF Core. This was done when I was developing the prototype for this application. So we are now going to use EF Core to generate a database for our shopping cart application. The classes that we have just created, representing our entities, will be used by EF Core to generate the corresponding database tables within a database that EF Core will create for us. In order to generate our database with the relevant tables through Visual Studio, let's install two NuGet packages. To do this, right-click the Dependencies node within our shoponline.api project. Click the Manage NuGet Packages menu item. Click the Browse tab on the NuGet Package Manager dialog. Let's search for Entity Framework Core.SQL Server. And this is the package we want to install. Let's click the Install button, then the I Accept button. Great. Let's search for the second package that we need to install. The reason we are installing this package is because we want to run our migrations from within Visual Studio, as opposed to using the .NET CLI for this purpose. Note that you would use different commands when running migration commands using the .NET CLI, as opposed to the commands you would run when using Visual Studio. So let's search for Entity Framework Core.Tools. And this is the package we want. Let's install the Microsoft.Entity Framework Core.Tools NuGet package. The next step is we must configure a connection string in order to connect our application with the database that we wish to create using Entity Framework Core code-first migrations. So let's open the appsettings.json file within our shoponline.web project. Within the connection string that I'm configuring here, I'm including my server name, which is Gavin Lon's PC, the database, which I wish to name Shop Online, And we are going to use a trusted connection to connect our shopping cart application's web API to our database. So let's include trusted_connection equals true within our connection string. Note that I have named my connection string Shop Online Connection. Let's create our database context class. Let's first create a folder named Data within our shoponline.api project. Let's add a class named shoponline_db_context to our new data folder. So in order to make this class represent our EF Core database context, we need to implement code so that our shoponline_db_context class inherits from EF Core's DB_context class. You can see there's a red squiggly line under DB_context. This is because we haven't yet brought in the Microsoft.EntityFramework Core namespace. An easy way to include the appropriate using directive through Visual Studio is to press Ctrl+ and then select the appropriate menu item from the menu that is presented to us through Visual Studio. Let's create the constructor for our shoponline_db_context class. We must add a parameter to the constructor that we have just generated. The parameter is named options and is of the generic type db_context_options, which has the data type shoponline_db_context passed as an argument to it. We can then write code to pass the argument that will be passed to our shoponline_db_context class constructor to the base class from which it inherits, i.e. the db_context class. Now, because I want to focus on the shopping cart workflows at this stage, and don't want us to be distracted by the implementation of administrative CRUD operation functionality, we are going to seed our database with certain data. This is data that I've already prepared. So we are not going to include create, read, update, and delete functionality regarding the creation and maintenance of product data at this stage. We are going to seed our database with product-related data. We are going to seed our database with the relevant data so that we can move directly to the creation of our shopping cart functionality. So in order to seed the database appropriately, we can override a method that exists within the db_context base class. This method is named onModelCreating. An easy way to generate the relevant override code for this method through Visual Studio is to type in the word override and then press the spacebar. We can then select the onModelCreating item from the drop-down list presented to us within Visual Studio. I have already prepared the code for seeding our database, and this code can be found at this location on GitHub. So let's go to the appropriate GitHub location and copy this code to our clipboards. Let's then paste the code from our clipboards into the onModelCreating method. The next step is to let Entity Framework Core know, as it were, about our entities. So we can do this by using the Entity Framework Core dbSet generic type. So for each of our entities, we need to appropriately include a public property of type dbSet within our Shop Online DB context class. To register our Shop Online DB context class for dependency injection, let's open the relevant program.cs file. Then we can simply add this code here to register our Shop Online DB context class for dependency injection. Note that our code is reading the connection string that we configured in the app settings.json file. We are now ready to generate a migration using EF Core. So let's launch the NuGet Package Console Manager window from within Visual Studio, like this. We can then type the appropriate command to generate a migration. So let's type in add-migration followed by the name of the migration we wish to create. So when I run the add-migration command, I get an exception. I've found out that this exception occurred because at present the shoponline.web project is set to my startup project within the relevant solution. So if you get this exception, all you need to do to fix this is make the shoponline.api project your startup project, like this. So let's try again. And now we don't get the exception, and it works as expected. And you can see code within the up method of the migration class that we have just generated. This code creates our database and the relevant tables. This method also contains code that seeds the relevant database tables with the data that I prepared prior to creating this video. The down method contains code to undo the changes made by code contained within the up method. To run our migration, all we need to do is type the update-database command within the NuGet Package Manager console window, like this, and then of course press enter. And now, if we look at SQL Server Management Studio, we can see that the Shop Online database has been created. The database tables have been appropriately created based on the entities we created using C# classes. The relevant database tables have been seeded with the data created from the code we included within the onModelCreating method, which resides within the Shop Online DB context class. The data with which we have seeded our database contains product and user information. This has been done so that we can focus on the shopping cart functionality and not worry at this stage about implementing code for create, read, update, and delete functionality regarding products sold by our fictional online store. Here are just a few notes about running migrations. Please note that if you have run a migration or more than one migration and are not happy with the changes made to the database, you can undo the changes made by running this command, update-database followed by a 0. The number 0 is a special case that means before the first migration and causes the effects of all migrations to be rolled back. You may wish to remove the migrations after this. You can remove a migration that has not yet been used to update the database by running the command remove-migration. The remove-migration command will remove the last migration that has not yet run. Note that if, for example, you have updated the database with multiple migrations, and you wish to roll back the changes to before a particular migration was run, you can roll back your changes to that particular state by running the migration that was run directly before the migrations that were run that contain the changes you wish to roll back. This is the second part in a series of videos dedicated to building a shopping cart application using Blazor and a RESTful web API. In this video, we are going to start with the workflow that involves retrieving product data from our database and returning the data to the client Blazor component. The code for this functionality will be implemented within a web API component. So in this tutorial, we'll start to develop our web API component. Before we do this, let's create the classes that represent the data that will be passed between the web API component and the Blazor component. You might be thinking, but we have already created the classes to represent the data for our application, for example, product, product category, cart, cart item, etc. Yes, we did create these classes that represent our entities in the previous part of this video series. These entity classes directly map to the database tables that were generated when we ran the relevant migration. The function of these classes can be seen as blueprints for their corresponding database tables. When we pass data between the web API component and the Blazor component, we don't necessarily want to pass the exact data defined by the properties in the classes that represent the database entities. For example, in this tutorial, we are going to create code that returns the product data from the web API component to the Blazor component. The product class contains certain product-related properties, one of which is the category ID. A particular category ID value could, for example, denote that a particular product falls under the electronics category and could, for example, be a laptop. Or, for example, the product could fall under the furniture category and could be, for example, a couch. The category ID property within the product entity is a foreign key from the product category entity. From a human perspective, the category ID property does not have much meaning because it contains a numeric value. So it wouldn't, for example, make much sense to display the category ID to the user. We may want to pass the relevant category name in addition to the product information defined in the product class. So to facilitate this, we can create a new model that contains all the relevant product data as well as the relevant category name, which is included in the product category entity and not the product entity. So it makes sense to create a new model to represent the data that in this case we wish to pass from server to client. We need a model that includes all the product information as well as the category name. The type of model I am referring to is known as a DTO, or Data Transfer Object. This type of model includes the data that needs to be passed between server and client. So a DTO is an object that defines how the data will be sent over the network. The classes that represent our entities that we created in the first tutorial directly map to their corresponding database tables. These classes represent the structure of certain tables in our database. We can create DTOs data transfer objects that are based on the underlying entity classes, but may be differently shaped based on the data that needs to be passed between client and server. We are going to create a standard library project to house our DTOs. So let's create a new project within our solution. Let's select the appropriate class library project template. Let's name our new project shoponline.models. Let's delete the default class generated for us by Visual Studio. Let's create a folder named DTOs. So let's create the DTOs that we are going to use in our application. Now, the only DTO that we are interested in at the moment will be named Product DTO. But let's create the other DTO classes that will be used later on in the development of our application, as well as the Product DTO class. The DTO classes will be explained in more detail at appropriate points during the development of our application. Let's create a class named CartItemDTO. Let's make sure our new class contains the public access modifier. Let's create the properties for the CartItemDTO class. ID as integer, product ID as integer, cart ID as integer, product name as string, product description as string, product image URL as string, price as decimal, total price as decimal, and QTY as integer. Let's create a new class named CartItemToAddDTO. Let's ensure that our new class contains the public access modifier. So, cart ID as integer, product ID as integer, and QTY as integer. Let's create a new class named CartItemQTYUpdateDTO. Let's ensure that our new class contains the public access modifier. CartItemID as integer, QTY as integer. Let's create a class named ProductDTO. This is the DTO that we are going to use in this tutorial. Let's ensure that our new class contains the public access modifier, ID as integer, name as string, description as string, image URL as string, price as decimal, QTY as integer, category ID as integer, and category name as string. Great, so we have created the classes that represent our DTOs, data transfer objects. Let's go to our shoponline.api project. So we are now going to start coding the logic for our first workflow, starting with the Web API component. This workflow simply involves retrieving product data from our database and returning the data to the client Blazor application. The Blazor application will contain code that displays the relevant product data to the user. So now our Shop Online DB Context class has been registered for dependency injection. We'll see in a bit how we are able to implement code to ensure that an object of type Shop Online DB Context is injected into relevant classes. We are going to use the repository design pattern to abstract our data handling layer. Repositories are classes or components that encapsulate the logic required to access data sources. We can use repositories to centralize common data access functionality, which has the benefit of facilitating better maintainability, easier unit testing, extensibility, and cleaner code. The best way to understand the repository pattern is to implement the relevant code. So let's write the code for our product repository functionality. So let's create a folder named repositories. Within the repositories folder, let's create a folder named contracts. Within the contracts folder, let's create an interface named iProductRepository. Let's create 4 method definitions within our new interface. We want all these methods to run asynchronously, so all the method definitions within this interface will return generic task objects. Our first method is named getItems and returns an IEnumerable collection of type product. So the IEnumerable collection is passed as a type argument to the task object. As discussed, this is so the method that implements this method definition can run asynchronously. The other methods follow a similar pattern. Let's define the method definition for a method named getCategories. Let's define a method definition for a method named getItem, which contains a parameter of type integer named ID. Let's define a method definition for a method named getCategory, which contains a parameter of type integer named ID. So we have defined the interface that we want a class named ProductRepository to implement. So let's create a class directly within the repositories directory named ProductRepository. And the first thing we need to do is write the code to implement the iProductRepository interface. So let's do that. We can see a red squiggly line under iProductRepository. This is because we need to bring in the shoponline.api.repositories.contracts namespace. A quick way to do this is press Ctrl, and then select the appropriate item from a list provided by Visual Studio, like this. The red squiggly line is still there. This is because Visual Studio is telling us, as it were, that we need to implement code for all the method definitions that we have defined within the iProductRepository interface. So let's press Ctrl once again and select the appropriate item from the list presented to us. And Visual Studio generates the relevant code stubs for us. So Visual Studio generates default implementations for the relevant method definitions. So at this stage, we only want to implement the code logic relevant to the workflow that is the focus of this video, i.e. returning a collection of product data to the client side calling code, in this case our Blazor component. We are going to need to use the Shop Online DB context object to interact with our Shop Online database. As you will recall earlier, we registered the Shop Online DB context object for dependency injection. This means that we are able to gain access to an object of type Shop Online DB context by defining an appropriate parameterized constructor in our product repository class. So let's create the code for this. An easy way to automatically generate a constructor within Visual Studio is type CTOR and then press the tab key twice, like this. Then in order to indicate to .NET that we want an object of type shop_online_db_context to be injected into this constructor, all we need to do is define a parameter within our constructor of type shop_online_db_context, like this. Let's bring in the appropriate namespace. And we can get Visual Studio to create an appropriate private read-only member variable to reference our shop_online_db_context object by pressing Ctrl- and selecting the appropriate item from the list presented to us by Visual Studio. Great. So for the workflow that is the focus of this tutorial, we only need to implement code for 2 of the method definitions within the iProductRepository interface. So at this point, we are only going to implement code for the getItems method and the getCategories method. So let's implement code for the getItems method. All we want this method to do is return all the products from the products table. So let's write the code for this. Note, we want our code to run asynchronously, so we must include the await keyword here. Notice how once we have typed in the await keyword, that the async keyword automatically appears in the method definition for the getItems method. If you include the await keyword within a method, the method in which you include the await keyword must appropriately contain the async keyword. Note that to include the toList async extension method here in our code, we must bring in the Microsoft.EntityFramework core namespace. And that's it. We have written the code to return an IEnumerable collection of products data from our database. So let's implement the code to return the product categories from our database. We can do this by implementing the appropriate code within our getCategories method, like this. Great. So we have now implemented the code for retrieving product data from our database. The next step is to write code to return the appropriate data to the calling client. So to do this, we need to create an appropriate controller class. Before we create our controller class, let's delete these classes that were generated by default when we first created our Web API project. These classes are obviously not going to be used in our application. So now let's create a class within our controllers directory. Let's ensure that we select the appropriate controller class template. Let's name this class ProductController. So the first thing to do is to write the code so that an object of type ProductRepository is automatically injected into our controller class's constructor via dependency injection. Let's also ensure that we have a read-only private field that references the object passed in via dependency injection. But we haven't yet registered our product repository class for dependency injection. So let's write the code for this. Let's open the program.cs file. Let's implement the code to register the product repository class with the dependency injection system. Notice how we use the addScoped method to register our ProductRepository class for dependency injection. We could have used the addTransient method or the addSingleton method to register our ProductRepository class with the dependency injection system, but in our case, addScoped is the appropriate method for this purpose. Very basically, using addTransient would mean that a new instance of the relevant object is provided to every class that requires the relevant object to be injected. Using addSingleton would mean that the same instance of the object is injected into the relevant classes for every HTTP request. Using addScoped means that the same instance of the object is injected into relevant classes within a particular HTTP request. Note that in this case, a new instance of the relevant object will be created for each HTTP request. Let's create a method definition for an action method named getItems. We want our action method to run asynchronously. The type that is passed to the generic task object is of the generic action result type. One of the core benefits of returning an action result is that, as well as returning the requested data from an action method to the client, an appropriate response status code can also be returned. For example, a HTTP status code of 200 means the request has succeeded. A status code of 404 represents that a resource could not be found, and a HTTP status code of 500 represents that an internal server error occurred. So we need to pass the type of data that we wish to return to the client as a type argument to the action result generic type. So we want to return an IEnumerable collection of type product DTO to the client. So the first thing we need to do is create a project reference to the shoponline.models project, because this is where our product DTO class resides. Then let's bring in the shoponline.models.dtos namespace. Great. Let's name our action method getItems. Each action method in our controller must map to a particular HTTP verb. For example, get, post, push, delete, etc. Our getItems action method will be used for getting product data and returning that product data to the client. So the appropriate HTTP verb for this action method is get. So to indicate this to .NET, we need to decorate our getItems action method with the HTTP get attribute. So let's implement the code logic for our getItems action method. Let's first create a try-catch block. An easy way to do this in Visual Studio is to type in try followed by pressing the tab key twice. So let's write code that calls the ProductRepository class's getItems method asynchronously to return an IEnumerable collection of type product to our action method. We want to include the category name associated with each product in our collection, so let's write code to return a collection of product category objects to our action method. We'll write the code that joins our collection of products with our collection of product categories in a bit. So you may have spotted that the code in this action method is not ideal at the moment. It is not ideal because we are retrieving a collection of products and a collection of categories in two separate queries to the database. A more performant way for retrieving the product collection and related category data would be to appropriately use the include extension method within the relevant LINQ query in the getItems method within the ProductRepository class. The use of the include method would join the data retrieved from the products database table with related data retrieved from the product categories database table and allow for the products data and related category data to be returned through one query. I'm going to leave the code as it is for now. We'll optimize this code for performance by using the include extension method, as I've just described, toward the end of the course. So if either the products variable is null, or the product categories variable is null, let's return a status code of not found to the calling client code. So in this case, our web API will return a HTTP status code of 404, meaning that relevant data was not found, or a relevant resource was not found. So in this case, it means that the client request failed, and the reason for the failure is that an essential resource could not be found. Else, we want to join the collection of product categories with the collection of products, so that we can return a collection of product DTOs to the calling client code, which will include the category name. Remember, the product DTO definition contains a category name property. In order to get the category name for each product in the collection, we need to join the collection of type product to the collection of type product category. We are going to use LINQ for this purpose. In order to avoid creating too many lines of code within our action method, we are going to create an extension method to return a collection type of product DTO to our action method. So let's create a folder named extensions. Let's create a class within our extensions folder named DtoConversions. Note that in order to create an extension method, we need the class that houses our extension methods to be static. Let's create our extension method. So the extension method must be a static method, and we want to return an IEnumerable collection of objects of type product DTO to the calling code. Let's name our method convert_to_DTO. The first parameter in an extension method must be the type of an object on which we want to be able to call the convert_to_DTO extension method. So by convention, this parameter definition must also be preceded by the this keyword. So on an IEnumerable collection of type product, we want to be able to call the convert_to_DTO method in order to convert an IEnumerable collection of type product to an IEnumerable collection of type product DTO. The logic for this method will, using a LINQ query, join a collection of type product to a collection of type product category, and return a collection of type product DTO to the calling code. So the second parameter of the convert_to_DTO method is of a type that is an IEnumerable collection of type product category. Let's write the logic for our extension method. So let's write a LINQ query that joins the collection of type product to the collection of type product category and return a collection of type product DTO. Great. So let's go back to the ProductController class and finish the code for the getItems action method. So in order for the convert_to_DTO method to be accessible on the products variable, we must of course bring in the shoponline.api.extensions namespace. Then let's pass in the product categories variable as an argument to the convert_to_DTO extension method. Then we can return a HTTP status code of 200 to the calling code. We can do this by returning the results of an OK method, which accepts an argument of a collection of type product DTO. So this code returns a HTTP status code of 200 as well as a collection of type product DTO to the calling client code. So if for some reason an exception occurs during the running of the relevant server-side code, in this case we want our code to return a HTTP status code of 500 to the calling client code, coupled with an appropriate error message. Let's keep the error message simple. Great. So if we open our program.cs file, you can see the configuration code here related to Swagger and Swagger UI. Swagger is an interface description language for describing RESTful APIs expressed using JSON. The configuration relevant to Swagger UI here means that our Web API project is equipped with a basic web-based user interface where we can see relevant information regarding our controllers and action methods. We are also able to use the Swagger user interface to test and debug our action methods when we run our Web API code interactively through Visual Studio. So let's run our code to see this in action. And here we are presented with the Swagger UI. Let's test our getItems action method. We can do this through our Swagger user interface like this. Excellent! In the next part of this video series, we'll write the calling client code that calls the action method that we have written in this tutorial from our Blazor component. We'll also write the code to appropriately display the products returned from our Web API component to the user. So in the next tutorial, we'll start to develop our Blazor WebAssembly component. So this is the third part of a video series where we are building a shopping cart application using Blazor WebAssembly and Web API. We are building our application on .NET 6, which at the time of writing this video is the latest version of .NET. We are now at a stage where we have built our database using Entity Framework Core, Code First migrations, and have started implementing code for the first workflow, which simply involves retrieving product data from our database and displaying this product data to the user. In part 2, the previous part of this video series, we implemented the code that retrieves the relevant product data from our database and returns the data to the calling client. This code was implemented in an action method within a controller class named ProductController. This class was created within our shoponline.api project, which contains the code for our Web API component. In this video, we want to start developing the code for our client-side Blazor component. So in this video, we'll implement code within our Blazor component to call the action method that we developed in the previous part of this video series and display the returned data to the user. So let's get started. The first thing we need to do is copy the URL to our clipboards, which is the URL of our Web API component when we run the shoponline.api project through Visual Studio. We are doing this so that we can appropriately configure our Blazor component to point to the appropriate local Web API URL, so that we can easily test our application through Visual Studio during the development phase of our shopping cart application. One way we can access the relevant URL is to simply run our Web API project. So let's copy this part of the URL, which we can refer to as the base URL or base address, to our clipboards. Then let's open the program.cs class within our shoponline.web component. So here is a block of code that was automatically included within our shoponline.web component, whereby the HTTP client object is configured for dependency injection. This means that we will automatically have access to a HTTP client object from appropriately written classes within our Blazor component. We will be using the HTTP client object to call relevant action methods within our Web API component. So, in order for our HTTP client component to point to the Web API component on our local machines, we need to replace the argument that is currently being passed to the URI constructor here with the base URL that we have just copied to our clipboards. So let's appropriately paste the base URL copied to our clipboards here. Great. So we are going to wrap the functionality that handles calls to our Web API component within services. These services are simply C# classes that wrap the functionality for handling interactions with our Web API component. So the first thing to do is create a folder named Services. Then within the Services folder, let's create a folder named Contracts. Let's create an interface named iProductService within the Contracts folder. So we'll build up the methods for the product service class over time when appropriate during the development of our application. We are just going to implement code for one method in this video. So let's create a method definition for our method in the iProductService file. We want our method to run asynchronously, so our method will return a task object. In this case, we are going to write code to return a generic task object because this method must return a value to the calling code. The type of value that we want to return to calling code is an IEnumerable collection of objects of type ProductDTO. Let's name this method getItems. In a bit, we'll implement code for this method to retrieve relevant product data from the appropriate action method that resides within our Web API component. We have a red squiggly line under ProductDTO. The ProductDTO type is defined within the shoponline.models project, so let's create a project reference to the shoponline.models project. Let's then bring in the namespace for the ProductDTO type. Great. Okay, so let's create the code to implement our iProductService interface. So let's create a class named ProductService directly within the Services folder. Let's create a constructor. So we want to tell .NET, as it were, that we want a HTTP client object to be injected into our ProductService class. So to do this, we simply define a parameter of type HTTP client within our constructor definition. Then let's generate a read-only member variable to reference the object of type HTTP client that will be injected into this class at runtime. The next thing to do is to implement the iProductService interface. So let's write the code for this. Let's generate the code stub for the method that we have defined within the iProductService interface. let's write the code logic for the getItems method. Let's first generate a try-catch block. Within the try block, let's write code to call the getItemsAction method that resides within the ProductController of our Web API component. You can see we are using the generic getFromJSON async method to call the appropriate action method within our Web API component. We are passing in a type argument, which is an IEnumerable collection of type product DTO, to the getJSON async generic method. We are doing this because we want our getFromJSON async method to return an IEnumerable collection of type product DTO. So this method will translate the data, which will be in JSON format, returned from the Web API component, into an object of type IEnumerable, which is strongly typed with the type product DTO. Notice that we are passing in text here, which denotes where the collection of resources that we want to retrieve from our Web API component can be found. The Web API component will know, as it were, to invoke the getItemsAction method within the ProductController class of our Web API component, based on this information passed as an argument to the getFromJSON async method. We have a red squiggly line under getFromJSON async. So to get rid of the error flagged by the C# compiler, we must bring in the system.net.http.json namespace. This is where the getFromJSON async extension method resides. The getItemsAction method that we are calling in our Web API component will return a collection of objects of type product DTO in JSON format. The JSON data will automatically be translated into an IEnumerable collection of objects of type product DTO for us. So our products variable here will reference the returned result, which will be an IEnumerable collection of objects of type product DTO. So we could add additional code to handle the HTTP response returned from the Web API component. We'll look at writing code for this when we look at exception handling in more detail in a later tutorial. For now, I just want to go through the basics of returning data from the Web API component and displaying the data to the user from code created within the Blazor WebAssembly component. So now we are going to create our Razor component, where we will create the code to display the data to the user, i.e. the data returned from the service functionality we have just created. Razor components are fundamental to Blazor. Simply put, Blazor apps are built using Razor components. So within the Pages folder, let's create a Razor component named products.razor. Note that we are able to create our code to call our service functionality directly within our Razor file within the code section here. In the interests of creating cleaner code, we are going to abstract the code for consuming our service functionality within a base class. Our Razor component will then inherit from the appropriate base class. So let's create a C# class named productsBase. So in order for our base class to be inherited from our Razor component, our base class must inherit from a class named componentBase, which resides within the Microsoft.ASP.NET Core.Components namespace. So let's go to our Razor file. We want our products.razor component to be invoked when our application is first loaded. So we can ensure that this happens by declaring information about our Razor component's root at the top of this page, like this. Note that when a Razor component with an @page directive is compiled, the generated component class is provided a root attribute specifying the component's root template. Here we are just providing a /. This means that when the URL contains only the base URL for our Blazor component, that our products.razor component will be invoked. And now we can write code within our Razor file that declares that our products.razor component inherits from the products base class, like this. So let's go back to our products base class. Let's create a property to facilitate dependency injection of an object of type iProductService into our products Razor component. So let's define a public property of type iProductService named ProductService. So to indicate to .NET that we want an object of type iProductService injected into this property, we need to decorate the appropriate property with the inject attribute, like this. And of course, we mustn't forget to register our ProductService class for dependency injection. So to do this, let's open the program.cs class and implement the relevant dependency injection configuration code like this. Great. Let's create a public property to expose an IEnumerable collection of objects of type product DTO. This collection will be accessible to the relevant Razor code that we'll implement in a bit to output the product data. So now we want our code that retrieves our product data from the server, our Web API component, to run when the product's Razor component is first invoked. We can do this by overriding a function named onInitializedAsync. So to override a method, we can type override, press the spacebar, and then select the method that we wish to override. We want to override a method named onInitializedAsync, so let's select the appropriate item here. The onInitializedAsync method is associated with a Blazor lifecycle event. Let's read a little bit about lifecycle events on this Microsoft Docs webpage. The Razor component processes Razor component lifecycle events in a set of synchronous and asynchronous lifecycle methods. The lifecycle methods can be overridden to perform additional operations in components during component initialization and rendering. If the component is rendering for the first time on a request, create the component's instance. Perform property injection. Run setParametersAsync. Call onInitializedAsync. If an incomplete task is returned, the task is awaited, and then the component is rendered. So within the onInitializedAsync method, let's implement the code for retrieving our product data from our Web API component, like this. We are using the object of type iProductService that will be injected into this class at runtime to return the relevant product data to our product component. Let's implement code for outputting the product data. So if the product's property is null, i.e., has not yet been retrieved from the server, we can output a loading indicator to the user. So while the data is being retrieved, this loading indicator will remain on the user's screen. Else, when the relevant product data has populated the product's property, We want code to execute that outputs the product data to the user in an aesthetically pleasing style. Let's bring in the namespace of our product DTO class. We can include this using directive in the _imports.razor file here. And this means that this using directive will apply to the other Razor files as well. Let's write a LINQ query here that sequentially takes 4 items at a time from the collection of product DTO objects. Images relevant to each of the products has been uploaded to GitHub. Please feel free to download these images. Each image maps to a row of data in the products table in our database. We seeded our database with the relevant data in the first part of this video series. Let's then implement code to appropriately output the product data. Bootstrap 5 is being used to output each item of product data as a Bootstrap card. Later, we are going to abstract this code further to clean up the code a bit. The final code for this functionality is available on GitHub. The appropriate link can be found below in the description. For now, I just want to write code to display our product data appropriately to the user. It was pointed out in the comments section that my spelling of the word furniture is incorrect, both in the Shop Online DB context class and the sidebar in the prototype shopping cart application that I created in preparation for this video series. I don't know why I spelled furniture with an A like this, furnature, but clearly that's what I did. The consequence is that after you ran the migration to create and seed your database, the word furniture may be incorrectly spelled in your products database table and your products category database table. Of course, you may have spotted this and fixed this before creating and running the relevant migration. If not, the good news is that this is easy to fix. I thought that fixing this issue gives us a great opportunity to see how easy it is to fix issues like this during the development phase of our application using EF Core migrations. We can fix the relevant data simply by correcting the spelling issue within the onModelCreating method in the Shop Online DB context class. We can then generate a migration that will contain the code that can be used to update the database with the relevant fix. So if you ran your migration where the word furniture was spelled incorrectly within the onModelCreating method of your Shop Online DB context class, please follow along with these steps to fix the issue within your database. Please note that the appropriate spelling fixes regarding all instances of the word furniture have been uploaded to the relevant GitHub repository. Of course, a link to the relevant repository is included below in the description. So let's open the Shop Online DB Context class that can be found in the data folder within the shoponline.api project. Let's go to the onModel creating method. So let's press Ctrl F so that we can perform a find and replace on the incorrectly spelt word furniture. Okay, clearly I can't even make the excuse that this was a typo. Look at how consistent I've been in spelling the word furniture wrong. Right, let's replace the incorrect spelling of the word furniture with the correct spelling of the word furniture. So, 8 occurrences. And here are some instances where our find and replace did not fix the spelling, because our search was matching the whole word. So let's amend the relevant image file name references for these particular instances. Of course, make sure that furniture is spelled correctly for the relevant furniture folder and the relevant image files on your local machines. I did correct the spelling issue before I uploaded the image files to GitHub, so your file system should contain the correct spelling from when you downloaded the relevant files from GitHub. We can now invoke the Package Manager console window from within Visual Studio and create a migration to fix our issue. So let's create a new migration by typing in the add-migration command. And you can see that the appropriate code to fix the relevant data in our database is generated for us in a new migration class. If we are happy with the relevant migration code, we can run the update-database command to fix the relevant data in our databases. So let's do that. Great. So we are now ready to run our code. In order to run both the Web API component and the Blazor component simultaneously through Visual Studio, we can configure the shoponline.api project and the Shop Online web project to start up at the same time like this. But we want the shoponline.api project to start a little bit earlier. Before we run our code, let's delete the index.razor file from within our pages directory. This Razor component is also configured with the same root as we have configured for our product's Razor component. And we are not going to use the index.razor component that was generated by default in our application. So now when we first run this code, we are actually going to get an exception. I'll explain why in a bit, and then we'll take steps to resolve the issue. Let's press the play button to run the code. You can see here that we have an exception coming from our Blazor component. If we press F12 while our Chrome browsers are active, we can examine the relevant error message here. The exception is caused as a result of CORS, or Cross-Origin Resource Sharing. Cross-Origin Resource Sharing, CORS, is a HTTP header-based mechanism that allows a server to indicate any origins, domain, scheme, or port, other than its own, from which a browser should permit loading resources. Basically, this error occurs because our Blazor component has a different base URL to our Web API component. As a result of this, a security barrier prevents us from being able to access the relevant resources returned from our Web API component. Let's copy the base URL for our Blazor component to our clipboards. You'll see why we are doing this in a bit. We are able to configure a policy within our Web API project to explicitly allow for our Blazor component to access relevant resources. So to do this, let's open the program.cs file within our shoponline.api project and include the relevant CORS policy code, like this. So where you see the URLs in this block of code, please paste the base URL for your Blazor component for the relevant URL arguments. Note that we can configure both the HTTP version of our URL and the HTTPS version of our URL in this CORS policy code. And please ensure that you don't include a / character at the end of these URL arguments. Great. Let's run the code again. Excellent. We now have our product data appropriately displayed to us when we first load our application. So all is working fine, but if we look at our product.razor file, we can see that we have written quite a lot of code here. We can make this code that outputs a row of products reusable by abstracting this code into its own component, its own Razor component. By abstracting this code into its own Razor component, we are not only allowing for the relevant code to be reusable by other Razor parent components, we are also creating cleaner code. So to do this, we can create a child Razor component to house the code that outputs the relevant product data. So let's create a Razor component named displayProducts.razor. Let's create a C# class named displayProductsBase, which will of course be the base class for our displayProducts.razor component. Let's make our displayProductsBase class inherit from the component base class. We want a parent Razor component to be able to pass an IEnumerable collection of objects of type product DTO to our display products Razor child component. We can achieve this by creating a parameter property within our display products base class, like this. It is important to note that a parameter property is decorated with the parameter attribute. let's go to the displayProducts.razor file and implement code to inherit from our displayProducts base class. Then we can go to our products.razor file and cut the relevant code and paste it into our displayProducts.razor file, like this. Then we can modify the code appropriately so that the code within the displayProducts.razor file is traversing the IEnumerable collection passed to the displayProducts child razor component's products parameter. A child component cannot be accessed directly through a browser and therefore does not contain a root declaration. A child razor component must be invoked from within a parent razor component. So let's go to the product's parent razor component and call the child displayProducts child component through this declarative code. Notice how we are able to pass the relevant collection of objects of type product DTO to the product's parameter that we defined within the displayProducts child component. And the code for calling the child razor component from the parent razor component is very much like typical HTML code. By abstracting the code for displaying a list of products to the user into a child razor component, we have created cleaner code, facilitated easier code maintenance, and the displayProducts child razor component can be reused from within other parent components. This will be demonstrated in a later tutorial. Let's run the code. Great. So, let's say that a requirement arises where we need to display each product item under its appropriate product category. So to answer this requirement, we can create an appropriate LINQ query to group our objects of type product DTO by product category, like this. We can also include a category heading for each group of products. And of course, each row containing the grouped products must reside within the loop, like this. Let's also include a dividing line between each product group. Let's run the code. Great! We can clean up this code even further by abstracting the relevant LINQ code within the appropriate base class, like this. Great. And let's say that we only wish to display 4 items for each product category. We can achieve this by using LINQ's take extension method like this. Excellent. The last thing I'd like to do is add basic animation effects to each of the Bootstrap cards we are using to represent our products. So to add a CSS class that only applies to a particular Razor component, we can add a style sheet with a name that adheres to a specific naming convention. So let's add a CSS style sheet to the Pages directory and let's name this style sheet displayproducts.razor.css. This naming convention ensures that the styles contained within this file will only apply to the displayproducts.razor component, which is the component that outputs the Bootstrap cards that represent our products. This tutorial is not about CSS, so I've pre-prepared the relevant CSS code. So I'm just going to paste the relevant code into the displayproducts.razor.css file here. This code is of course accessible from within the relevant GitHub repository. Let's run the code. And you can see that when we hover our mouse pointers over a card, the relevant image scales and a box shadow appears. These basic animation effects have been included to enhance the user's UX. Excellent! So this is the 4th part in a series of videos dedicated to building a shopping cart application on .NET 6 using Blazor WebAssembly and Web API. We have now created our first workflow, which involves retrieving product data from the database and displaying the data to the user in an aesthetically pleasing style. We have built our database using Entity Framework Core. We have implemented code using the repository design pattern within a Web API component in order to return product data from our database to a calling client. In the last part of this series, part 3, we implemented code for our Blazor WebAssembly component to call an appropriate action method within our Web API component using a HTTP GET request in order to retrieve product data from the server and display the data to the user in an aesthetically pleasing style. We want to create functionality to retrieve data for a specific product from the server and display the details of that product to the user. So when the user clicks on a particular product, only the details for that specific product are displayed to the user. The user can then decide whether or not to add the product to the user's shopping cart. A button will be provided within the Razor component responsible for displaying the relevant product's details, whereby a user can click this button and add the relevant product to the user's shopping cart. We'll implement the code for the Add to Cart button in the next tutorial. So let's go to the Web API component. Let's open the ProductRepository class and go to the GetItem method. You can see that currently we have a default implementation for this method, which was created when we generated the code stubs through Visual Studio of the iProductRepository interface that we are implementing in the ProductRepository class. So as the name implies, the getItem method returns data regarding a single item. So we can use the findAsync method to retrieve the data pertaining to the product that matches the ID value passed into the getItem method through code like this. The next step is to expose the functionality to a calling client by implementing code that gets executed in reaction to an appropriate HTTP GET request. So we want the getItem functionality to execute when a calling client makes an appropriate HTTP GET request for product data that can be identified in the system with the ID value passed to our Web API component from the calling client. We can implement code that creates an appropriate HTTP response through creating an action method within our ProductController controller class. So let's create a method within the ProductController class to return data for a particular product. To speed things up, let's duplicate the getItems action method that we created in the second part of this series and change the code appropriately so as to implement the functionality for the getItem action method. We only want to return data for one object of type ProductDTO rather than an IEnumerable collection of objects of type ProductDTO to the calling client. So let's change the return type appropriately. Let's include a parameter named ID, which is of type integer. This ID parameter denotes the ID value of the product data for which the client wishes to have returned from our Web API component. Within the HTTP GET attribute, let's include the appropriate root template information. Our getItem action method contains a parameter of type integer named ID. So for the getItem action method, it is appropriate to pass in an argument of type string to its corresponding HTTP GET attribute that denotes the appropriate root template for this action method. So let's use the product repository object passed into our controller class via dependency injection to call the getItem method that we have just implemented within the product repository class. So if the returned value is null, this means that the resource does not exist. So let's pass a response to the calling client that includes a bad request status code. We can do this in code by returning the result returned from the bad request method, like this. So let's say we also want to include the name of the category under which the relevant product falls in the returned object. As we know, we only have the ID of the category under which the returned product falls within the product entity. We don't have the facility to store any other information pertaining to the product's category within the product entity. So we need to write code to get the category information from the product category entity. We can then include the product information and the category information in an object of type ProductDTO and return the relevant object of type ProductDTO to the calling client. So let's implement code for the getCategory method within the product repository class to retrieve data for our specific category based on the category ID passed into this method. Let's then write code within our getItem action method to appropriately call the getCategory method on the object of type iProductRepository, like this. The next step is to write the code that merges the data pertaining to a specific product with the data pertaining to the relevant product's category into one object of type ProductDTO. in order to write the code for this in a clean way, we can create a convert-to-DTO extension method overload within our DTOConversions class. So the convert-to-DTO extension method currently within our DTOConversions class converts a collection of products and a collection of product categories appropriately into a collection of objects of type ProductDTO, and returns the collection of objects of type ProductDTO to the calling code. We want our new convert-to-DTO extension method overload to convert one object of type product and related object of type product category into one object of type ProductDTO and return this object of type ProductDTO to the calling code. This is basically so that we can include the relevant product data and the category name within one object. Our ProductDTO type facilitates this. So we can write code to perform the relevant conversion like this. We can now go to our getItemAction method and call the convert-to-DTO extension method, which is now available on this object of type product, to return the appropriate object of type ProductDTO to our action method. We can then write code to return a HTTP status code of 200 OK, along with the relevant object of type ProductDTO to the calling client by appropriately returning the result of the OK method and passing in the appropriate object of type ProductDTO to the OK method. If an exception occurs for some reason during the execution of the getItemAction method, we have code here that will return a HTTP status code of 500, denoting an internal server error, to the calling client along with an appropriate error message. Great. So let's write code within the Blazor component to make an appropriate HTTP call to the server-side code that we have just implemented. So let's open our iProduct service interface. Let's include a method definition for a method where we will implement the code to call the getItemAction method on the server. We want this getItem method to run asynchronously, so we are returning a task object. The getItem method is returning a value, so we must pass the return type as a type argument to the generic task type here. This method contains a parameter of type integer and is named ID. This ID parameter denotes the ID value that is used to identify a specific product. So let's implement the getItem method in the product service class. Let's generate a try-catch block. In the previous part of this series, part 3, we implemented code for the getItems method that uses the HTTP client object's getFromJSON async method to call the relevant server-side action method. This method calls the relevant action method, but also handles translating the returned JSON data into the appropriate object type. I'm going to use the getAsync method to call the relevant action method in our getItem method. This method doesn't convert the returned JSON data to the appropriate object type. We need to write code for this separately. We'll do that in a bit. The getAsync method returns a HTTP response object. So we can use the returned object to first ascertain as to whether our HTTP request to the server was successful. So this code checks that the relevant status code falls within the success range. So if the call is successful, we want code to execute that checks if our HTTP request has returned a response with content. If there is no content returned from the server, we want code executed that returns the default value associated with the product DTO type, like this. So the C# default value for a user-defined type, which is a reference type, will be null. So this is just the way I'm choosing to handle the scenario where the call to the server is successful, but for some reason no data is returned from the server. So when the call is successful and content is returned from the server, we want code to execute that translates the JSON data returned from the server into an object of the appropriate type. Else, if the call to the server is not successful, we want code to execute that handles the exception. So here we are just going to throw the exception at this point. And we can pass the message sent back from the server as an argument to the exception object, like this. Within the catch block, we could implement code to log the exception or handle the exception in an appropriate manner that we choose. Let's implement appropriate code within the getItems method to also include exception handling functionality. So let's create a Razor component within the Pages folder. Let's name this component ProductDetails.Razor. So this is the component where we'll implement the code to display details regarding a specific product. Let's create the base class for our product details component, and let's name this component Product Details Base. Let's implement the code for our Product Details Base class. We want the ID parameter that denotes the identifier for a specific product to be passed into the component, so let's create a parameter named ID that is of type integer. We need to decorate this property with the parameter attribute. We also need to ensure that our base class inherits from the component base class. So we want an object of type iProductService to be injected into our product details component. So we can do this by including a property within our base class of type iProductService and decorate the relevant property with the inject attribute. Let's include a property of type ProductDTO within our base class, and let's name this property Product. Let's include a string property to store an exception message. So we want code to execute when our Blazor component is first invoked. So we can ensure that this happens by writing the relevant code within a method that overrides the onInitialized async method. To generate the appropriate onInitialized async method, let's type in override, followed by pressing the spacebar, and then let's select the appropriate method from the list presented to us. Let's generate a try-catch block. Within the try-catch block, let's appropriately call the getItem method on the injected object of type iProductService. The returned value is assigned to our product property, which we can then access from our ProductDetails.razor file. If an exception occurs, we want the exception message to be assigned to the error message property. Let's implement code to output details regarding the relevant product. So let's ensure that we include the appropriate root template at the top of the file. We can use the page directive for this purpose, and notice how we are including the ID parameter here. This is because an appropriate ID parameter must be passed to this Razor component when this Razor component is invoked. Let's write the code logic. So while the product property is null and the error message property is null, we want a loading indicator to be displayed to the user. Else, if an error occurs, in which case the error message property will not be null, we want the error message to be displayed. Please note that for the sake of this example, we are writing functionality to display the error message returned from the server to the screen. In a complete application, it would be more appropriate to output a user-friendly, non-technical error message to the user and log the actual error message returned from the server. Else, we want to output the details of the relevant product in an aesthetically pleasing style to the user. And of course, Bootstrap 5 classes are being used here to output the data in an aesthetically pleasing style. Great. Then let's go to the display products.razor file and include the appropriate value for the href attribute within the anchor tag that wraps the cards that represent the products sold in our online store. So we want this link to invoke the product details Razor component. We need to include the appropriate ID value, denoting the identifier for a specific product, within our href attribute value here. Let's run the code. Great! Let's abstract the code that outputs an exception to the user in its own Razor component, so that we can reuse this component from within multiple parent Razor components. This is also a cleaner way of implementing the code that displays an error message to the user. Let's write code to force an exception to occur. So we know that a product with an ID of 1000 does not exist in the system. So in this case, the server will send back a response code indicating that a bad request has been made. Let's run the code. Great! Lastly, it would be better in terms of a user's UX if an appropriate animated loading indicator was displayed to the user while the user is waiting for data to be displayed. So, if we navigate to this site here, we can copy the relevant HTML and CSS code for an animated loading indicator of our choice. These loading indicators here can be used within our application free of charge. So let's select this one. Let's copy the HTML and the CSS code for the loading indicator of our choice and integrate the code within our application. The cleanest way to integrate this code into our applications, in my opinion, is to abstract the loading indicator code within a Razor component. As discussed in the previous part of this series, part 3, we are able to create a CSS file that only applies to its corresponding Razor component by naming the relevant CSS file in a way that adheres to a specific naming convention. So if the name of the Razor component is display spinner, we can create a CSS file that will only apply to this Razor component by naming the relevant CSS file display spinner.razor.css. So we can now reuse the spinner functionality for multiple parent components. I look forward to presenting the next video in this series where we'll create the functionality for adding products to a shopping cart. This is the 5th part in a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So we have completed the implementation of 2 workflows. The first workflow involves retrieving the data pertaining to the products sold by our online store and displaying the data in an aesthetically pleasing style to the user. The second workflow involves displaying details for a particular product to the screen in response to the user clicking on a card representing the relevant product. In this video, we'll create the functionality whereby the user clicks the Add to Cart button, which is available on the screen where details for a particular product are displayed. This button click action will result in the relevant product being added to the user's shopping cart. After the user has clicked the Add to Cart button, the user will subsequently be navigated to a screen that displays data pertaining to the products currently contained within the user's shopping cart. So let's get started. So let's first implement the functionality for the server-side code. So let's go to our project that contains the functionality for our Web API component. In the second part of this video series, we implemented the repository design pattern for functionality to handle database interactions regarding the products sold by our online store. So we now want to create the code for handling the database functionality pertaining to the shopping cart. So let's create an interface that contains the method definitions for the shopping cart repository class that we'll create once we have created its interface. So let's create an interface named iShoppingCartRepository. Let's create a method definition for a method named addItem. As the name suggests, the code that we'll implement for this method will add a particular product to the relevant user's shopping cart. Let's add a method definition for a method named updateQTY. When a user first adds a product to the user's shopping cart, the quantity of the relevant product added to the user's shopping cart will be 1 by default. The implementation for this method will involve updating the quantity of a particular product that is currently contained within a user's shopping cart. Let's add a method definition for a method named deleteItem. As the name suggests, the functionality for this method will involve removing a particular product from the user's shopping cart. The getItem method will contain functionality for retrieving data regarding a particular product that is currently in the user's shopping cart. The getItems method will contain functionality for retrieving data for all the products that are currently in a particular user's shopping cart. So let's create a class named ShoppingCartRepository. Let's write code to implement the iShoppingCartRepository interface that we have just created. Let's position our mouse pointers appropriately and press Ctrl in order to bring in the appropriate namespace, i.e. where the iShoppingCartRepository interface resides. Let's press Ctrl and generate the code stubs for the method definitions that we included within the iShoppingCartRepository interface. So in this video, we are going to implement functionality for 3 of the methods that we have defined within the iShoppingCartRepository interface, namely addItem, getItems, and getItem. Before we do this, let's create a constructor. Let's add a parameter to our constructor that is of type shopOnline_DB_context. By including this parameter, we are indicating to .NET that we want an object of this type injected into our shopping cart repository class at runtime. We have already registered the shopOnline_DB_context type for dependency injection. The shopOnline_DB_context type is the EF Core Database Context object that is used for handling data manipulation and data retrieval functionality in relation to our application's database. So let's implement the functionality for the addItem method. Let's first write a LINQ query that ensures that the product that the user is attempting to add to the user's shopping cart exists in the products table. So if the item returned from our LINQ query is not null, we want code to execute that adds the relevant product to the cart items database table. This denotes that the product has been added to the user's shopping cart. So let's implement the code to add the item to the cart items database table. Once we have called the addAsync method, we must also remember to call the SaveChangesAsync method. Then we can write code to return the entity that has been successfully added to the cart items database table, like this. If an item is not successfully added to the database, we want code to execute that will return null to the calling code. So, in order to avoid a product being added twice to our user's shopping cart, let's implement code that checks to see if the relevant product already exists within the user's shopping cart. Let's implement the code for this in a private method that returns a Boolean value. Then we can use the private method we have just created, like this, to perform the relevant check. So we have ensured that only one instance of a particular product can be added to the user's shopping cart. Please note that the user will be able to purchase more than one instance of a particular product by appropriately modifying the QTY or quantity field. We'll implement this at a later stage. Let's implement the code for the getItems method. Let's write code that returns the results of a LINQ query pertaining to the products currently stored within the user's shopping cart. Then let's write code for the getItem method. Let's write code that returns the results of a LINQ query, which is data pertaining to a particular product currently stored within the relevant user's shopping cart. Let's add a controller class to the controllers folder. Let's name this controller class Shopping Cart Controller. Firstly, let's create a constructor that contains two parameters, one of type iShoppingCartRepository and the other of type iProductRepository. Let's create two read-only fields to reference the objects that will be injected into our controller class at runtime. Let's of course not forget to register the iShoppingCartRepository type for dependency injection. So let's implement the code for the getItems action method. Let's use our shopping cart repository object to return the items currently stored within the relevant user's shopping cart. If no items are contained within the shopping cart, we want code to execute that returns a HTTP response of no content to the calling client. This is denoted by a HTTP code status of 204. So this means the client HTTP request was successful, but no items related to the client's request are present in the system, therefore no content can be returned to the calling client. So we are returning a collection of type CartItem DTO to the client from the action method. We have just written code that retrieves a collection of objects of type CartItem. We want to return a collection of objects of type CartItem DTO to the calling client. The CartItem DTO type contains additional data regarding the relevant product. We don't have the additional data at this point, so let's use the product repository object to retrieve a collection of objects of type product. We can then write code to join our collection of CartItem objects with the collection of objects of type product using a LINQ query and return an appropriate collection of objects of type CartItem DTO to the calling client. So let's keep this code clean and implement a LINQ query in an extension method to return the relevant collection of objects of type CartItem DTO to the getItems action method. Before we do this, let's write code to throw an exception if no products exist within the system, because if there are no products in the system and the user is attempting to add a product to the user's shopping cart, well, this won't make any sense. So this means an exception has occurred. Let's write code in a catch block that returns a HTTP status code of 500 to the calling code. So if for some reason an exception occurs during the execution of the getItems action method, we want an internal server error 500 HTTP response to be returned to the client. So let's go to the DtoConversions class and implement another extension method overload named convertToDTO. We'll be able to call this extension method overload on an IEnumerable collection of type CartItem to perform the relevant conversion functionality. Let's go to our getItems action method and call the extension method we have just created to return the appropriate collection of objects of type cartItem DTO. We can then write code to return this collection to the calling client with a HTTP response status code of 200 OK. Let's implement the code for the getItem action method. You can see here that the code is very similar to the getItems action method, but we, of course, are only returning one item of type cartItem DTO to the calling client instead of a collection of objects of type cartItem DTO. So let's write code for converting an object of type cartItem to an object of type cartItem DTO. To do this, let's go to the DtoConversion class and implement the code for the appropriate extension method overload. We can then call the relevant convert to DTO extension method on the relevant object of type cartItem to perform the appropriate conversion functionality. Let's write the functionality for handling a post request from the client whereby a user is attempting to add a product to the user's shopping cart. So let's write code to call the addItem method on the shopping cart repository object that will be injected into our controller class at runtime. We want to return the newly added item of type cartItem DTO to the calling client. So we can call the same conversion code that we implemented for the getItem method for this purpose. It is important to note that it is standard practice for a post-action method to return the location of the resource where the newly added item can be found. This location will be returned in the header of the HTTP response returned from this method. We can use the createAtAction method to ensure that we are adhering to this standard practice. So the relevant resource can be found at the URI, Universal Resource Identifier, pertaining to the getItemAction method, and we are including the ID of the newly added resource here. And for the final argument, we are including the newly added object, which we have now converted to type cartItem DTO. If you'd like to read more about the createAdAction method, I've included an appropriate link below in the description. And we of course need to decorate this action method with the HTTP post attribute. Let's run the shoponline.api project through Visual Studio and you can see the new action methods and relevant DTOs are present on the Swagger UI web page. Great. Let's implement the relevant code for our Blazor component. So let's go to the shoponline.web project. Let's create a new service class where we'll implement code that interacts with the action methods that we have created within our shopping cart controller class in our Web API project. Firstly, let's create the appropriate interface in the contracts folder for the relevant service class. Let's name this interface iShoppingCartService. Let's create a method definition for the getItems method and the addItems method. Let's create a class named Shopping Cart Service. Let's generate the code stubs for the methods defined within the iShoppingCartService interface. Let's create a constructor for the shopping cart service class. Let's include a parameter of type HTTP client as a parameter within our constructor. This parameter indicates to .NET that we want an object of type HTTP client injected into this class at runtime. Let's implement the code for the addItem method. So basically, this code calls the post-action method that we implemented in the shopping cart controller class. If the response HTTP status code is within the success range, let's check to see if any content was returned. If no content was returned, let's return the default C# value for the cartItem DTO type to the calling code, which will be null. If content was returned from the server, let's return the object representing the newly created shopping cart item to the calling code. This will, of course, be an object of type CartItemDTO. Let's include the relevant exception handling code. Let's implement code for the getItems method. So I'm deliberately including an incorrect URI, Universal Resource Identifier, reference here so that this will force an exception when we run the code. We'll fix this a little bit later after we have run the code that tests how an application handles the relevant exception. This code simply places a HTTP GET request to the getItems action method, and if content is returned, returns the relevant content to the relevant Razor component, i.e., the calling code. Let's go to the product details base class and implement a button click event handler method for the add to cart button. Let's name this click event handler method add to cart underscore click. Let's make sure that we have registered the iShoppingCart service type for dependency injection. Let's implement code that ensures that an object of type iShoppingCartService is injected into the product details base class at runtime. Then our code within the add to cart underscore click event handler method calls the add item method on the injected shopping cart service object to add a product chosen by the user to the user's shopping cart. let's go to the product details.razor file and implement the code that calls the add-to-cart_click event handler method. So we have started with the implementation of the shopping cart functionality. We have not implemented user registration or login functionality, i.e. membership functionality, in this application. We could implement code to bring down user-related information from the server when the user first logs onto the system. The information could include the user's user ID and the user's cart ID. So because we haven't implemented login functionality, let's temporarily hard-code the user's cart ID and user ID in a class within the project that contains our Blazor functionality so that we can progress with the implementation of the shopping cart functionality. So in the first video in this series, we seeded the data with data for 2 users. So let's say that we are going to run the code from the perspective of the user that has a user ID of 1 and a cart ID of 1. So we can now pass in the hard-coded cart ID value here, along with the relevant product ID and a quantity of 1. When a user adds a product to the user's shopping cart, by default, 1 instance of that product is added to the user's shopping cart. Let's strategically add some breakpoints in the Blazor project and the Web API project and run the code. And let's invoke the functionality for the workflow that we have just implemented in code by clicking a product that we wish to add to the shopping cart. And then let's click the Add to Cart button. Great. If we look at the cart items database table, we can see an item has been appropriately inserted into the relevant table. Let's test this again. Great! Let's create a Razor component that will be responsible for rendering a collection of product data pertaining to products that have been added to the user's shopping cart to the screen. So let's add a Razor component named shoppingcart.razor. Let's add a base class for the shopping cart Razor component. Let's name this class shopping cart base. Let's implement code for the shopping cart base class. So our shopping cart base class must inherit from the component base class because we want this class to be the base class for the shopping cart Razor component. Let's write code for injecting an object of type iShoppingCartService into our class at runtime. Let's include a property for referencing a collection of objects of type CartItemDTO. This property will be used within the shoppingcart.razor file for code that displays the relevant data to the screen. Let's create the code to override the onInitialized async method, where we'll implement code for assigning the relevant collection of items returned from the server to the shoppingCartItems property when the Razor component is first rendered. Great. Let's implement the code for the shoppingcart.razor file. Let's include the page directive at the top to declare the root template for our shopping cart Razor component. Let's use the inherits directive to ensure that we are using the shopping cart base class as the Razor component's base class. So while the shopping cart items property is null and the error message property is null, we want a spinner loading indicator to be displayed to the user. If the error message property is not null, we want the relevant error message to be displayed to the user. Else, we want code to run that displays in an aesthetically pleasing style the data representing a collection of products that have been added to the user's shopping cart. We are using Bootstrap 5 classes for styling the HTML elements in our Razor file. Now that we have written the code for displaying a collection of products data for products added to the user's shopping cart, let's write code that navigates the user to this screen after the user clicks the Add to Cart button. So let's go to the Add to Cart _click event handler method within the product details base class and implement the relevant code. So we can use an object of type navigation manager to navigate the user to the relevant screen. So let's write code to ensure that an object of type navigation manager is injected into our Razor component at runtime. Let's then invoke the navigate to method on the navigation manager object to navigate the user to the shopping cart screen. Let's run the code. And an error message is displayed to us. This is because we are forcing a 404 not found error to occur at the moment. We have included an incorrect path to the endpoint that returns the collection of cart item DTO objects within the getItems method of the shopping cart service class. We need to appropriately include a reference to the shopping cart controller name within this URI reference. So let's correct this URI, Universal Resource Identifier, by appropriately including the relevant controller name here. Great. This is the 6th part in a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So, we have created 3 workflows. Let's recap. The first workflow involves retrieving products data from the database and displaying the products data to the user in an aesthetically pleasing style. The second workflow involves retrieving details for an individual product and displaying the relevant details in an aesthetically pleasing style to the user. The third workflow involves the user adding a product to the user's shopping cart and the user being navigated to a screen that displays a list of products contained within the user's shopping cart. In this video, we'll create the workflow that involves a user removing a product from the user's shopping cart. Let's get started. Let's start by implementing this server-side code. Let's go to our shoponline.api project and open the shoppingcartrepository.cs file. let's implement the code logic for the delete item method. So we can use the ID value that will be passed into this method to find the entity that we wish to delete from the cart items database table. We are using the findAsync method to find the relevant entity using the primary key field, which is the ID field. If we find the relevant entity, if the item returned from the findAsync method is not null, we can use the remove method to remove the relevant entity from the cart items database table. Then we mustn't forget to call the saveChangesAsync method to commit the relevant change to our database. In order to make this delete functionality available to calling client code, let's create an appropriate endpoint within our Web API component. So let's go to the shopping cart controller class and create an appropriate action method that will call the relevant delete item method that we have just implemented in the shopping cart repository class. Let's decorate our delete item action method with an attribute that declares that this action method corresponds to the HTTP delete verb. So far in the development of our application, we have created endpoints that correspond to both the get and post HTTP verbs. We are about to implement the logic for an endpoint that corresponds to the delete HTTP verb. Let's declare the relevant root template information for our action method by passing an appropriate string argument to the HTTP delete attribute. This information includes a definition for the ID that needs to be part of the URI, Universal Resource Identifier, pertaining to the entity that a client wishes to delete. So we are essentially enabling a calling client to delete a specific resource from the system. Let's create a try-catch block. A simple way to create the relevant code for this is to type try followed by pressing the tab key twice. Let's call the delete item method on the shopping cart repository object that will be injected into the constructor of this controller class at runtime. If the entity that the client wishes to delete cannot be found, we want code to execute that returns a HTTP response code of not found 404 to the client. The information that we want transferred across the network for the relevant entity that the client wishes to delete is of type cart item DTO and not the type cart item that is returned from the delete item method called on the shopping cart repository object. In the previous part of this video series, part 5, we implemented an extension method overload named convertToDTO within the DtoConversions class. This extension method can be called on any object of type cart item. Before we appropriately call the convertToDTO extension method, we must retrieve the relevant product entity from the database, so let's write the code to achieve this. Then let's call the convertToDTO method on the object of type cart item, returned from the shopping cart repository class's delete item method, to convert the relevant object of type cart item to an object of type cart item DTO. Then let's write code to return a HTTP response code of OK200 to the client along with the relevant object of type cart item DTO. Let's complete this method by writing code that executes if for some reason an exception is thrown during the execution of the code logic within the delete item action method. Let's go to our Blazor component. So let's go to the shoponline.web project. Let's add an appropriate new method definition to the iShoppingCart service interface named deleteItem. Let's open the shopping cart service class and implement the code logic for the deleteItem method. If the HTTP response code returned from the server falls within the success range, we want code to execute that returns an object of type CartItem DTO to the calling code. If the call to the server is not successful, we want null to be returned to the calling code. Let's open the shopping cart base class within the Pages folder. Let's implement code for a method that handles a button click event. So this method will be called when a user clicks a delete button that we'll create in a bit in the shoppingcart.razor file. Let's appropriately call the deleteItem method on the shopping cart service object that will be injected into our Razor component at runtime. So this code will call the appropriate action method on the server side that will delete the relevant entity, CartItem, from our database. So we want the results of this deletion operation to be reflected on the user interface, which means we need the shopping cart Razor component to re-render once the deletion operation has completed successfully. We could call the appropriate getItems method and retrieve all the relevant shopping cart items that are currently saved to our database for the relevant user and assign the results to the shopping cart items property. And the result of the deletion operation would then appropriately be reflected on the UI. However, we can implement code for a solution that will be more performant for this purpose than the solution that I've just expressed, i.e. that involves an additional call to the server-side code. We can reflect the results of a deletion operation on the UI by simply deleting the relevant CartItem object from the client-side collection of cart items referenced by our shopping cart items property. By deleting the relevant item from the client-side collection, we are avoiding a trip, as it were, to the server side. This could result in a significant performance benefit. So let's create a private method responsible for removing the relevant item from the client-side shopping cart items collection. We first need a variable that references the object within the shopping cart items collection that we wish to delete. So let's create another private method that contains code for returning a specific object within the shopping cart items collection. Let's then call our new private method to return the object that we wish to delete from the shopping cart items collection to our remove cart item method. We can then implement code to delete the relevant item from the relevant client-side shopping cart items collection. But there is a problem with this at the moment. Our client-side collection stored within the shopping cart items property is currently of type IEnumerable. The IEnumerable type is fine for when we need to traverse through the items in the relevant collection, but we don't currently have an easy way available to us to remove an item from the relevant client-side collection. One solution to this problem is that we can change the type of our client-side collection to type list. We must also appropriately change the return type of the delete item method definition in the iShoppingCart service interface, and of course we must also appropriately change the return type for the implementation of this method in the shopping cart service class. Let's go back to the shopping cart base class and use the remove method on the shopping cart items collection, which is now of type list, to remove the relevant item from the relevant client-side collection. Let's appropriately call our remove cart item method from within the delete cart item underscore click event handler method. Let's create the delete button within the shoppingcart.razor file. Let's use Blazor's @onClick syntax to ensure that our delete cart item underscore click functionality is triggered when the user clicks our new button. Let's run the code and test our method. Great. Okay, so I don't like this empty screen displayed to the user here when the user no longer has any cart items saved to the user's shopping cart. So let's ensure that status information is outputted to the user for the case where the user's shopping cart is empty. So we can do this by using the count method. So if the count method returns a value greater than 0, we can output the data contained within the shopping cart items property, as well as the relevant shopping cart summary information. Else, let's output a basic message to the user informing the user that the user's shopping cart is empty. Let's run the code. Great. So I think rather than display the text remove on the relevant button, I think the standard trash icon would look better. Let's use Font Awesome for this purpose. I'm going to use an appropriate CDN, Cloud Delivery Network link, to reference the relevant Font Awesome CSS file. So if we go to this website, we can copy the relevant link here, and we can then paste it into our index.html file in order to include Font Awesome icons within our application. We are now able to reference the Font Awesome trash icon like this to display the trash icon on our delete button. Excellent! I hope you have enjoyed this video. I look forward to presenting the next video in this series, where we'll continue to develop our shopping cart application. We are going to implement the update quantity functionality in the next video. This is the 7th part of a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So, in the previous part of this series, we created functionality whereby a user can delete an item from the user's shopping cart. In this video, we are going to create the functionality whereby a user is able to update the quantity of a particular product that has been placed within the user's shopping cart. A notable feature that we'll add is the showing and hiding of the Update QTY button. So we only want the Update QTY button to appear when the user changes the appropriate value in the field denoting the quantity of a particular item in the user's shopping cart. When the relevant field is changed, the relevant Update QTY button appears once the user has clicked the Update QTY button to update the quantity of a particular item in the user's shopping cart. We want the Update QTY button to disappear. To achieve the appropriate showing and hiding of the Update QTY button, we are going to invoke a JavaScript method. This brings us to an important question. How do we integrate JavaScript into our Blazor WebAssembly component? In this video, we are going to look at how we can use Blazor's JavaScript interoperability feature to interact with JavaScript code from within our Blazor WebAssembly component. We'll implement this functionality toward the end of the video, so please stick around to the end to learn about JavaScript interoperability with Blazor. To start with, let's create the server-side code for the Update QTY functionality. So let's get started. Let's go to the shoponline.api project. Let's open the shopping cart repository class. Let's implement the code logic for the Update QTY method. First thing to do is reference the item that we wish to update. So if we are able to find the relevant item within our database, and therefore the item variable will not be null, we can then update the QTY field with the value passed in from the client. And to commit the change to the database, we must of course call the SaveChangesAsync method. Let's write code to return null to the calling client for when the item is not found within the database. Let's expose the update quantity functionality to our calling client through an action method. Let's open the shopping cart controller class. Let's create an action method named UpdateQTY. Let's appropriately call the UpdateQTY method on the shopping cart repository object to update the relevant resource with the QTY value passed into our action method by the client. Let's use our convert to DTO method to appropriately convert the cart item object into an object of type cart item DTO. We can then write code to return the relevant object of type cart item DTO to the calling client, along with the HTTP code status of 200 OK. Let's include the appropriate exception handling code. So we have so far created action methods that correspond to the HTTP get verb, the HTTP post verb, and the HTTP delete verb. The other two most common HTTP verbs are the HTTP put verb and the HTTP patch verb. The HTTP put verb and the HTTP patch verb are both associated with the performance of resource updates. The difference between these two HTTP verbs is that the HTTP put verb is associated with action methods that modify a resource, where the client sends data that updates the entire resource. The HTTP patch verb, however, is associated with action methods that partially update the respective resource. So we want our update QTY method to update only the QTY field for a cart item resource. So this means it is appropriate to associate our update QTY action method with the HTTP patch verb. We can write declarative code to indicate that this action method is associated with the HTTP patch verb. To do this, we can appropriately decorate the update QTY action method with the HTTP patch attribute, like this. Note that we are passing in data to the HTTP patch attribute that provides necessary route template information. This indicates that the URI for the relevant endpoint must appropriately contain the ID of the resource that the client wishes to modify. Right, let's write the appropriate code for the Blazor component. So let's go to the shoponline.web project. Let's open the iShoppingCart service class. Let's open the shopping cart service class to implement the code logic for the update QTY method. Let's first serialize the DTO that we wish to pass to the server into JSON format. Let's create an object of type string content so that we can appropriately pass the relevant data in the appropriate format to the server. Let's call the patch async method on our HTTP client object and pass in the appropriate URI. As well as the relevant data to the patch async method. If the HTTP response status code falls within the success range, let's include code that returns the appropriate data returned from the server to the calling code. Let's go to the shopping cart base class. let's create a method that will handle the update QTY button click event. So the calling code will pass in the ID of the shopping cart item that the user wishes to update, as well as the relevant quantity value. If the quantity value is greater than 0, meaning that the quantity or QTY field value is valid, we can appropriately call the update QTY method on the shopping cart service object to call the relevant server-side code in order to update the database appropriately. Else, if the calling code passes in an invalid quantity, let's set the quantity field for the relevant cart item to 1. Let's go to the shoppingcart.razor file. Let's add an input field that will allow a user to modify the quantity of a particular item in the user's shopping cart. Note that we are using Blazor's @bind syntax to bind each quantity input field to the corresponding property of the appropriate object of type cart item DTO stored within the shopping cart items collection. This means, for example, that if the QTY property for a cart item DTO object stored within the shopping cart items collection is modified, that this modification will immediately be reflected on the UI in the appropriate quantity input field. Let's create the Update QTY button that a user can click in order to update the quantity of a particular item. Let's use Blazor's @onClick syntax to call the appropriate event handler method that we have created within the shopping cart base class. Let's stand by our convention to use the _click suffix for these type of event handler methods. So let's change the name of the relevant method from update QTY cart item to update QTY cart item _click. Then we can write code to pass in the appropriate values to our update QTY cart item _click method. Let's test the code. Great. So we haven't yet written code so that the total quantity and total price is reflected within the cart item summary information displayed to the user on the right-hand side of the user's screen. Let's implement the code for this. So firstly, let's include two properties within our shopping cart base class. Let's include a property to store the total price of the items within the user's shopping cart and the total quantity of the items stored within the user's shopping cart. Let's create a private method named setTotalPrice, which is responsible for calculating the total price of all the items stored within the user's shopping cart and assigning the result of this calculation to the relevant property. Let's create a private method named setTotalQuantity, which is responsible for calculating the total quantity of items stored within the user's shopping cart and assigning the result of this calculation to the relevant property. Let's create a private method named CalculateCartItemSummaryTotals. Let's call the setTotalPrice method as well as the setTotalQuantity method from within the CalculateCartSummaryTotals method. We want the total price of all the items stored within the user's shopping cart as well as the total quantity of items stored within the user's shopping cart to be reflected on the UI whenever a user action results in the state of the shopping cart changing. So let's appropriately call our CalculateCartSummaryTotals method from within the UpdateQTY_CartItem_click event handler method. The DeleteCartItem_click event handler method, and the onInitialized async method that is called when the Razor component is rendered. Let's go to the shoppingcart.razor file and implement the code that will result in the appropriate summary totals being reflected appropriately on the UI. Before we run the code, we must also include a method in the shopping cart base class that updates the total price property on the relevant object of type cart item DTO when the relevant quantity property is updated for a particular cart item by the user. So basically, if, for example, a cart item has a price of $50 and the user updates its quantity property from 1 to 2, we need to change the cart item's total price from $50 to $100. To calculate the total price is simply a mathematical operation of price multiplied by quantity. So let's create a method named UpdateItemTotalPrice. Let's call our getCartItemPrivate method to reference the relevant cart item. Then we can update its total price property with the result of the calculation that we have just discussed. We want our UpdateItemTotalPrice method invoked every time the quantity for an item within the user's shopping cart changes. So let's implement the code for this appropriately. Great. Let's run the code. Excellent. So let's look at JavaScript interoperability in a Blazor WebAssembly component. Let's implement the code so that our Update QTY button is only shown to the user when the state of the relevant input field changes. So let's first create a CSS file for our shopping cart Razor component. So let's create a CSS file named shoppingcart.razor.css. As discussed, when we create a CSS file that only applies to a specific Razor component, we must adhere to a specific naming convention. Let's create a CSS class named update-qty that contains the code display:"none. So we can apply this class to the Update QTY button like this to ensure that when the relevant Razor component first loads, that the Update QTY button is not displayed to the user. So the next step is to create a JavaScript method that is invoked when the quantity input field is changed by the user. This JavaScript method will be responsible for appropriately showing and hiding the relevant Update QTY button. Let's create a folder within the www root folder of our project named JS. Let's add a JavaScript file named shoppingcartfunctions.js to the JS folder. Let's create a JavaScript function named makeUpdateQTY button visible. This function accepts two arguments. One denotes the ID of the relevant cart item, and the other denotes a Boolean value. So in order to be able to identify the relevant button within our JavaScript code, we can apply a data attribute to the relevant HTML element. So let's go to our shoppingcart.razor file and include a data attribute named data-item ID and set its value to the ID of the relevant cart item. The code for the JavaScript function is fairly basic. Let's use our data attribute to reference the appropriate button element. We are using the data-item ID data attribute to identify a specific Update QTY button. If the Boolean value is true, we want code to execute within our JavaScript function to make the relevant button visible. If the Boolean value is false, we want our function to make the relevant button invisible. Let's appropriately reference our new JavaScript file from within the index.html file. Then we need to write code to detect when a quantity input field or QTY input field is changed by the user. We can use Blazor's @onInput syntax for this purpose. One might think that the @onChange syntax should be used for this purpose, but a method executed in response to the @onChange syntax will only be invoked when the relevant input field loses focus. We want our method to be invoked immediately when the relevant input field's value changes. So let's implement a method within the shoppingcartBase.cs class that will be invoked when a quantity input field is changed. So we want our makeUpdateQty button visible JavaScript function to be invoked when a quantity input field is changed. So how can we call a JavaScript function from within a Razor component? The answer to this is that we can use the built-in JS runtime type for this purpose. So let's create a property of type IJS runtime. Let's decorate this property with the inject attribute so that an appropriate object of type IJS runtime will be injected into our Razor component at runtime. We can then use the object to appropriately call our makeUpdateQty button visible JavaScript function like this. Let's go to our shoppingcart.razor file and appropriately call our updateQty_input method. Lastly, let's write code that calls the relevant JavaScript function to make the relevant updateQty button disappear once the relevant button has been clicked. Let's run the code. Excellent. This is the 8th part of a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So at this point, we have achieved quite a lot. We have created the functionality for displaying grouped products to the user. We have also created most of the functionality for the shopping cart. A user can now add a product to the shopping cart, remove a product from the shopping cart, and can update the quantity of a product that is contained within the shopping cart. So we now need a way for a user to be able to navigate to the shopping cart from anywhere within the application. We also want the user to be able to see at a glance how many items are currently contained within the user's shopping cart. Currently, the user is only able to navigate to the shopping cart through our application by adding a product to the shopping cart. We want the user to be able to see how many items have been added to the user's shopping cart at a glance, no matter where the user is within the application. For example, the user may be viewing the grouped products displayed to the user when the application is first launched and wishes to know how many items are currently contained within the user's shopping cart. We also want the user to be able to navigate to the user's shopping cart through our application from anywhere within the application simply by clicking a button. So we want to make this button accessible to the user from anywhere in the application. So in this video, we'll provide an appropriate solution for this. We'll provide a button in the header part of the UI that, when clicked, will navigate the user to the user's shopping cart. the quantity of items stored within the user's shopping cart will be displayed on the text of the relevant button. So the quantity value displayed on the relevant button must be kept up to date. So we must facilitate the change of the relevant quantity value whenever the number of items within the shopping cart changes. The code for the button containing the text representing the number of items in the user's shopping cart will be contained within its own Razor component, a Razor component we'll name Cart Menu. So this means we need to find a way to send data to the Cart Menu Razor component from other relevant Razor components, like for example, the Shopping Cart Razor component, whereby code must execute that updates the relevant quantity value when a change to the number of items stored within the user's shopping cart is made. In this video, we'll see how C# events can be used to facilitate communication of data between the loosely coupled Razor components within our application. Right, let's get started. Let's go to our Blazor client component. So let's go to the project named shoponline.web. Let's open the iShoppingCart service file. Let's create a definition for a C# event. Note that the action type is a delegate that doesn't return a value. So any method that the relevant delegate points to will be able to accept the arguments defined within the relevant delegate, but the method will not return a value. In our case, any method pointed to by this delegate will accept one argument of type integer. Let's create a definition for a method that is responsible for raising the relevant event to subscribed components. If what we are doing here is unclear to you, don't worry. It will become clearer to you as we develop the code in this video. Okay, so let's open the shopping cart service file. Let's implement the code for the interface items that we have just created. Let's implement the code for the raise event on shopping cart changed method. First, we need to check if our event has any subscribers. We can do this by evaluating the onShoppingCartChanged event object. So if the onShoppingCartChanged object is not null, this means that the event has subscribers. So if the event has subscribers, we need to write code that raises the event to those subscribers. We can do this by implementing the invoke method on the onShoppingCartChanged event object. Then we can send the appropriate integer value to each of our subscribers by passing in the appropriate integer value to the invoke method. So in the context of our application, an example of a subscriber will be a method within the cart menu Razor component that we'll create later in this tutorial. When the quantity of the items stored within the user's shopping cart changes, the event is raised and a custom method that will be created within the cart menu Razor component will be invoked in response to the quantity of items stored within the shopping cart changing. Basically, when the quantity of the shopping cart changes, the event is raised and any subscribed methods are called. This will be clarified with code that we'll create in a bit. So this event being raised will result in the new quantity of items stored within the user's shopping cart being displayed from within the cart menu Razor component. Let's open the productsbase.cs file. Let's write code so that an object of type shopping cart service will be injected into this Razor component at runtime. So the products Razor component is loaded When a user first launches our application, we want the user to be able to see how many items are currently stored within the user's shopping cart when the application is first loaded. So let's first appropriately call code on the server to retrieve the shopping cart items currently stored within the user's shopping cart. I can feel the comments flowing my way already. So I think I'll be preemptive and just say that I'm aware that this may not be the most performant way of doing this. But I want to focus on events in relation to Razor components in this tutorial. We will be optimizing the code in later videos. For example, by including local storage functionality. I don't want to make my videos too convoluted, so this is why I sometimes first create simplistic code in certain scenarios so that momentum is gained in the development of our application. And then, as I said, we can always optimize the code in later tutorials. Right, let's write code to calculate the number of items currently stored within the user's shopping cart. We can then use the shopping cart service object to raise the appropriate event, which will in effect send the quantity of items stored within the user's shopping cart to any subscribers. So this will result in the appropriate quantity value being displayed to the user in the header section of the layout of our application. Let's open the shoppingcartbase.cs file. So we want our event to be raised each time the quantity of items stored within the user's shopping cart changes. Let's create a private method named cartChanged. Let's rationalize our code a bit so that the cartSummaryTotals private method is called whenever this cartChanged method is called. And we want our event to be raised whenever the cartChanged method is called. We want our cartChanged method to be called whenever the state of the user's shopping cart is changed. So let's appropriately call our method from within the onInitialized async method. The delete cart item underscore click event handler method, and the update qty cart item underscore click event handler method. Notice that each time we write code to invoke the cartChanged method, we are replacing the call to the cartSummaryTotals method with the call to our new cartChanged method, because the calculateSummaryTotals method is now being called from within the cartChanged method. So let's create the code for the cart menu Razor component. This component will be displayed in the header section of our layout for our application. So let's create a Razor component called cartMenu.Razor within the shared folder. Let's write code so that an object of type iShoppingCartService is injected into our cart menu Razor component at runtime. Let's open the _imports.razor file and include a using directive that references the shoponline.web.services.contracts namespace. So we are not using inheritance for this component. So we can instead include code logic for this Razor component within the @code section of our Razor file. This is because our cart menu Razor component is not likely to contain a lot of code logic, so we don't necessarily need to abstract the code logic into a separate base class. Let's define a variable of type integer named shoppingcartItemCount. Let's create an override for the Razor component's onInitialized method. This method will be called when our Razor component is first rendered. So we want our Razor component to subscribe to the event that we created in the shopping cart service class. To achieve this, we can implement this code. This means that every time the relevant event is raised, the shopping cart changed method will be run. So we haven't yet implemented code for the shopping cart changed method, so let's do that. So all we are doing is updating our shopping cart item count variable with the quantity value passed into this method from code that executes to raise the relevant event. Note that we are calling Blazor's built-in stateHasChanged method here. This is an explicit way of telling Blazor, as it were, to re-render the relevant Razor component. So we are explicitly telling Blazor to re-render the component after the shopping cart item count variable has been assigned a new value from code that is raising the relevant event. The shopping cart item count will be used in the UI user interface code that we are about to create for displaying the new quantity of items stored within the user's shopping cart. So let's write the UI code, and this must exist outside the @code section. So we want a button displayed to the user that displays a value representing an up-to-date count of items currently stored within the user's shopping cart. We also want a user to be able to navigate to the user's shopping cart when this button is clicked. In order to prevent possible memory leaks, we can write code to unsubscribe from the onShoppingCartChanged event. So to do this, let's implement the iDisposable interface. Then we can implement code for the dispose method to unsubscribe from the onShoppingCartChanged event like this. So you can see that the plus equals operator is used to subscribe to an event, and the minus equals operator is used to unsubscribe from an event. Let's open the main layout Razor component from within the shared folder. This component is responsible for displaying the main UI layout of our application. We can ensure that our cart menu Razor component displays within the header section by including the appropriate tag for our cart menu Razor component here. So let's run the code. Excellent. So notice that when we are using a mobile view, when running the application, we are not able to see our header menu item. So let's write code to allow for users that are using our application in a mobile view to be able to see the count of items currently stored within the user's shopping cart, and also to be able to navigate to the user's shopping cart from anywhere within the application. We can do this by adding an appropriate menu item to the application's main menu for when the application is being used using a mobile view. So let's open the nav-menu.razor file from within the shared directory. This file contains the code responsible for creating our application's main menu. Let's add a new menu item to the main menu like this. Let's write code so that an object of type iShoppingCartService is injected into this Razor component at runtime. In the @code section, let's create a private variable of type integer named shoppingcartItemsCount. Let's implement the code to subscribe to the onShoppingCartChanged event. Let's implement the method that we want executed when the onShoppingCartChanged event is raised. Let's go to the appropriate menu item code and include the shopping cart item count variable so that the user is able to see from this menu item how many items are currently stored within the user's shopping cart. Now, we only want this menu item to be shown to users that are using our application using a mobile view. So we can ensure this by including the D-SM -none bootstrap class within the appropriate HTML element that represents the relevant menu item. Lastly, let's write code so that before this Razor component is garbage collected, i.e. before .NET frees the memory taken up by this Razor component, that the relevant method within this Razor component is unsubscribed from the onShoppingCartChanged event. Let's run the code. Excellent. So we have now completed all the functionality that enables a user to add items to the user's shopping cart, as well as remove items from the user's shopping cart. A user is also able to update the quantity of products within the user's shopping cart. So, of course, no point leaving the products hanging around in the user's shopping cart. The next logical step is for a user to purchase the products in the user's shopping cart. So, we are going to create a Razor component in this part of the course that denotes a checkout facility, whereby the user can purchase the products within the user's shopping cart. So, how do we create a payment facility so that users can purchase the items in the user's shopping cart? The answer is we must integrate a payment gateway into our application. So, if we navigate to this website, we can see here some useful information regarding payment gateways. What is a payment gateway? A payment gateway is a service that authorizes and processes debit/credit card or PayPal payments for online merchants and traditional brick-and-mortar businesses. A payment gateway facilitates these transactions by encrypting sensitive data and transferring it between a payment portal, a website or a mobile device, and the bank/front-end processor. If we scroll further down this page, we can see a list of the most popular payment gateway providers. You've probably heard of a few of them, like for example PayPal and Stripe. PayPal, Stripe, Square, SecurePay, WorldPay, Authorized.net, DtoCheckout.com, Braintree. I have a business account with PayPal, so I'm most familiar with PayPal. In this video, I'll give you a very basic guide on how you can integrate the PayPal payment gateway into your application. Even though I'm specifically using PayPal, the same fundamental principles will apply for other payment gateways. Please see the relevant instructions provided by your preferred payment gateway service provider on how you can integrate your preferred payment gateway into your applications. The payment gateway service provider will provide developers with information on how to integrate the relevant payment gateway into your application. It's not as difficult as you might think. All of the heavy lifting, as it were, is done through the third-party payment gateway. So, this tutorial is not a definitive or comprehensive guide on how to integrate a payment gateway into your application, but it will hopefully give you a very good idea of how to integrate a payment gateway into your applications. It all depends on your application's requirement on how you go about implementing relevant payment gateway integration functionality in your applications. Let me first present a brief disclaimer before we start this tutorial. This is not a definitive guide on integrating a payment gateway into your application. This is certainly not a final e-commerce solution. The purpose of this tutorial serves to give you a basic idea of how you are able to integrate a payment gateway into a Blazor WebAssembly application. If you wish to create an application that uses a payment gateway in a live environment, you'll need to research relevant information provided by your preferred payment gateway provider in order to gain a thorough understanding of how to create an e-commerce solution using the relevant payment gateway. Right, let's get started. Let's create a Razor component named checkout.razor within the Pages folder. Let's create a C# class named checkoutBase.cs within the Pages folder. Let's write code to ensure that the Checkout Razor component inherits from the Checkout Base class. As the name of our Razor component suggests, a user will navigate to this Razor component in order to purchase the items within the user's shopping cart. PayPal makes it easy for us to integrate the payment gateway functionality within our applications by providing us with sample HTML and JavaScript code. In order to copy the relevant HTML and JavaScript code, let's navigate to this PayPal web page. If we scroll further down the page, PayPal presents us with a few options. I'm going to use the first option here. Let's click the Start Setup button. Let's select the variable price list item here. Let's select the desktop option here. Then to copy the relevant JavaScript and HTML code, we can click the Copy Code button here. Let's navigate to our index.html page and paste the HTML and JavaScript code currently stored within our clipboards here. You can see here we have a JavaScript function named init PayPal button. This method contains callback methods like, for example, create order, and onApproved. The create order method is called by PayPal when an order is created, and the onApproved method is called after the relevant order has been approved by PayPal. Note that within the onApproved method, there is code that logs information about the order, which is sent back from PayPal after an order has been approved, to the browser console window. The relevant information is sent back from PayPal regarding the relevant order after the order has been approved by PayPal. So this gives us an idea of how our code integrates with PayPal. We also have a script tag here that references a script file at a specific PayPal location. The way in which we are able to link a PayPal account to our application is through this client-id parameter here. At the moment, we only have a placeholder value for the client-id parameter. I'll demonstrate a bit later how we are able to generate a valid client ID value that we can paste over this placeholder value here. I'll demonstrate this a bit later. We have this HTML code here that contains various fields and a placeholder for the relevant payment gateway related buttons that the user can use to start the payment process. The user will be able to pay using a valid debit or credit card by clicking this button, or if the user has a valid PayPal account, the user can use the user's PayPal account by clicking this button. For a particular integration requirement, we can tailor the sample code to our needs. So we are going to simplify the code here and remove code that is superfluous in relation to our particular requirement. So let's say that for a particular integration requirement, we only need the description field and the amount field. So we can delete the JavaScript code from the init PayPal button method here that references the HTML elements denoting the fields that we don't need. We don't need this code here, so let's delete it. We don't need this code because it is code used for validating user input. Code within our application will control what is entered into the appropriate fields, namely the amount field and the description field. Therefore, we don't need any user validation related code. In the onInit method, there is a lot of code relevant to user validation that we don't need. Let's delete the onInit method. Within the onClick method, we only need this code here that references the values that will be inserted into the amount and description fields at an appropriate time by certain code within our application. So let's copy the relevant code from the onClick method here. Let's paste it into the create order method here. Then we can simply delete the onClick method. You can see here in the onApproved method, we have code here that logs order information to the user's browser console window. This information is sent back from PayPal once a user's order has been approved by PayPal and contains details about the user's order. We'll examine the order information later when we test our code. You can see here that the sample code that we copied from PayPal includes a call to the init PayPal button JavaScript method. We want to control when the init PayPal button method is invoked. We'll implement the code to call the init PayPal button method using C# code and Blazor's JavaScript interoperability feature from within the checkout razor component in a bit. So let's remove the call to the init PayPal button from the index.html file. Let's cut this HTML code here and paste it into our checkout.razor file. This will allow the PayPal buttons to be available to the user when the user invokes the checkout razor component. For our particular requirement, let's say that all we are interested in is the description field and the amount field. So let's remove the HTML elements that we don't need for the implementation of our integration code with PayPal. We don't need the HTML elements that label the relevant fields, because we are going to make the amount field and description field hidden text fields. We don't want the user to enter any payment information. We are going to control the values that are inserted into these fields through C# code that we'll implement in a bit. We need this div element here because this tells PayPal, as it were, where we want the relevant PayPal gateway-related buttons placed within our UI. So, for our requirement, we don't want these fields to be visible to the user. So let's make these fields hidden text fields. So let's create the code for the checkout-base.cs class. We are going to want to call the init PayPal button JavaScript method that resides within our index.html file from within the checkout-base.cs class. So we need to write code that ensures that an object of type IJS runtime is injected into our checkout Razor component at runtime. This is so that we can utilize Blazor's JavaScript interoperability feature to call the init PayPal button JavaScript method that we copied from the relevant PayPal web page earlier. We'll write the code to call this JavaScript method in a bit. We need to reference the collection of shopping cart items, so let's create a property of type IEnumerable that is strongly typed with the cart item DTO type. Let's create a property named TotalQTY. Let's create a property named Payment Description. Let's create a property named Payment Amount. Let's create code to bind the PayPal-related hidden text fields we have implemented within the checkout.razor file to their counterpart properties by using Blazor's @bind syntax. So this means that every time relevant property values change, Blazor will automatically update their counterpart input fields, i.e. the input fields that contain the relevant @bind syntax in the checkout.razor file. The payment description and payment amount properties will be bound to the input fields implemented within the checkout.razor file. So this is one of the aspects involved in integrating our application with PayPal. We can communicate the total payment amount to PayPal through the payment amount property, and we can communicate whatever payment description we want by updating the payment description property. The JavaScript within the init PayPal button method references the fields that we have implemented using hidden text fields in the checkout.razor file, i.e. the amount field and the description field. The fields are bound to their counterpart properties within the checkout base class. We can use this description field to uniquely identify a particular payment. There are, of course, many different ways to implement this type of functionality. I've chosen this way for the sake of the example, in the interests of keeping the example simple, i.e. for teaching purposes. When we run the code and create a test order, once our order is approved by PayPal, we'll be able to inspect the data within our browser's console window, which is the data sent back from PayPal after our order has been approved. We'll see that one of the fields contains our unique description value. We want an object of type iShoppingCartService to be injected into our checkout Razor component at runtime. So let's create a property of type iShoppingCartService and ensure that it is decorated with the inject attribute. Let's override the onInitialized async method. Let's implement code to retrieve the user's shopping cart items. We'll look at code in a later tutorial, whereby we can use local storage functionality so that we don't have to make so many calls to the server. We can use local storage to improve performance, but we'll write this code in a later tutorial. So I'm writing code to create a new GUID here, so that we can use this GUID value to uniquely identify a particular order. Let's assign the total payment amount to the payment amount property. Let's assign the total quantity to the total QTY property. Let's create an identifier field so that we can uniquely identify a particular order. As I said earlier, I'm just doing this for the sake of this example. It is up to the developer to modify the appropriate code so that it is adapted appropriately in relation to the developer's particular requirement. So let's include an O for order, followed by the user's ID, and then followed by the unique GUID value within the payment description field. Let's override the onAfterRender async method. This method is called in response to the occurrence of a Blazor lifecycle event that occurs after the relevant Razor component is rendered. We can use the first render argument passed to this method to ensure that our code within this method is only fired once after our Razor component is first rendered. So, if first render is true, we want code to execute that uses our JS object to call the init PayPal button JavaScript method. So you can see how we are integrating our checkout Razor component with the sample JavaScript code that we included within the index.html file. This is, of course, the sample code we copied from PayPal, so as to perform our integration with their payment gateway. So the next step is to generate the client ID, whereby we can link our PayPal account to our application. So we need to do this through PayPal. Note that you are able to follow along with the next part of this tutorial, even if you just have a personal account with PayPal. You will, however, need a business account with PayPal if you wish to go live with the PayPal Payment Gateway functionality. PayPal provides a sandbox feature that we can use for development and testing purposes. But as I said, if you wish to go live, you'll need a PayPal business account. For instructions on how to create a PayPal business account, please navigate to this URL. So assuming you have a PayPal account, as stated, you are still able to follow along even if you just have a personal account and you don't have a business account. Let's log in to PayPal. Then let's click the developer menu option here so that we can use the sandbox feature to implement the server-side part of the integration functionality so that we can integrate the PayPal payment gateway into our application. You can then navigate to the dashboard like this. You can see here you have two options, one for Sandbox and the other for Live. We are going to use the Sandbox facility. If you want to go live with your PayPal payment gateway, you would use the Live facility. As discussed, you will need a PayPal business account before you are able to go live with the PayPal payment gateway. So to create the server-side functionality that we need in order to integrate the PayPal payment gateway into our application, click the Create App button. Let's give the app a sensible name and then create the app like this. We now have this client ID generated for us, and this is the key to how we can associate our client-side integration with our PayPal account. So let's copy this client ID value to our clipboards. Let's remain logged into PayPal, and let's appropriately paste the relevant client ID value to our index.html file here for the client-ID parameter. Great. While we are here, let's remove the enable-funding parameter here. Let's go back to PayPal. So, for testing purposes, PayPal allows us to generate mock credit card details. When we test our code, we are going to use the generated mock credit card details to make a test payment. We can generate mock credit card details by clicking the Credit Card Generator menu option here. And then I'm going to select the United Kingdom as my country first. And then to generate the mock credit card details, we can press the Generate Credit Card button here. So let's copy the relevant mock credit card details and save them somewhere, so that we can access them a little bit later when we test our application. Before we test the code, let's make sure that we can navigate from our shopping cart Razor component to our checkout component. So to do this, let's appropriately update the code within our shopping cart.razor file. Then we must also ensure that we have an appropriate @page directive at the top of our checkout.razor file. A user needs to be able to navigate directly to the checkout Razor component, so we must include appropriate root template information following the @page directive. And now we should be able to make a test payment through our application. Let's run the code. Let's add some items to our shopping cart. Let's proceed to checkout. Let's appropriately enter our mock credit card details, along with some appropriate made-up data regarding personal information, like address and phone number. Excellent. Now, if we press F12 within our Chrome browsers, we can see the data sent back from PayPal. In the onApproved callback method defined within the init PayPal button method, we have code to log data sent back from PayPal after an approved order has been made. We could implement code that extracts the relevant data from the returned data from PayPal and update our application's database in an appropriate way, depending on our requirement. That functionality is beyond the scope of this course, but hopefully this gives you a good enough insight of how to integrate the PayPal functionality into your application. But please read the relevant developer-related information provided by your preferred payment gateway service provider for information on how to create relevant integration functionality that best suits your requirement. And you can see here our custom description value that we created earlier in code has been sent back from PayPal along with the other order information, which contains the user ID value and a GUID value that our code generates for each order that is sent to PayPal. So let's finish the code for our checkout razor component. Let's say that we want to display a summary of items that the user is purchasing on the checkout UI, next to the PayPal buttons. So let's write the code for this. Please note this code can be copied from the relevant GitHub repository. I've included the location of the relevant GitHub repository below in the description. Let's test the code. Excellent. This is the 10th part and the penultimate video in a video series dedicated to building a shopping cart application on .NET 6. So, we are nearly finished building our shopping cart application. In this video, we are going to create functionality so that a user can filter the products in our store's product catalog by product category. We'll write code to query our database for all the product categories within our database and display them as menu items in the main menu contained within the sidebar section of our UI. When the user clicks one of the menu items denoting a product category, data representing the products related to that category will be appropriately displayed to the user. Right, let's get started. So in the first part of this course, we created our database through EF Core Code First migrations. A requirement to update the database's seed data or structure may arise, for example, due to a decision to include new functionality within the application, or perhaps just to correct a minor mistake made when the database was first created and seeded with data. Through EF Core Code First migrations, we have the agility that we need to make appropriate adjustments to our database during the development and testing phases of our application. So before we start writing code, we need to address a database-related requirement. We need to add a new column to the product categories database table where we can store relevant CSS code that denotes an icon used to represent a product category. We are, of course, going to use EF Core Code First migrations to address this requirement. So let's first update the product category entity class to include a new string property. And let's appropriately name our new property Icon CSS. We are going to need an appropriate DTO, data transfer object, to house the data that we send back to the client for when a client makes a request to the server for a collection of product category data. So let's go to the shoponline.models project and create an appropriate class to represent the relevant DTO. Let's go back to the shoponline.api project. Before we generate the relevant migration code, let's open the shoponline.db context class and update the relevant code for seeding our database within the onModelCreating method. So here we are including relevant font awesome CSS classes within the new field named Icon CSS. These classes will be appropriately referenced within our code to render appropriate icon images for each of the relevant product categories. So let's create our migration. And give it a sensible name. Great. Let's look at the migration code that we have just generated. Great. Let's run our migration through the update-database command. Excellent. So let's go to our shoponline.api project. So if we look at the product repository class, we can see that we have already written the code for returning a collection of product category objects. We need to expose this functionality to the relevant clients. So to do this, let's create an appropriate action method within the ProductController class. Let's create an extension method to convert the collection of product category objects to a collection of product category DTO objects. This may seem like a pointless exercise, because the shape of the product category class is exactly the same as the shape of the product category DTO class. It is important to understand that even though this step may seem unnecessary, that we are doing this due to design best practices. Why is this a design best practice? In the future, a new requirement may arise, for example, where a client may require additional data to be returned from the relevant action method. We want to maintain a clear separation of concerns between the DTO classes and the corresponding entity classes. The reason for this is that the relevant DTO classes can evolve independently from the relevant entity classes if required, without affecting their counterpart entity classes. So, a DTO class can, for example, be extended without affecting its counterpart entity class. Let's finish off the code for our action method. Great. So let's go to the shoponline.web project and write the calling client code for retrieving a collection of product category data. Let's create the relevant service code. Let's add an appropriate method definition to the iProductService interface. Let's implement the code for the interface that we have just created. So our code in this method is appropriately requesting a collection of objects of type product category DTO from the server. Great. let's create a Razor component that will be responsible for outputting the product categories as menu items inside our Blazor application's main menu that resides within the sidebar section of our application's UI. So within the shared directory, let's create a Razor component named Product Categories Nav Menu. Let's create a class named Product Categories Nav Menu Base. Let's write code so that an object of type iProductService is injected into our Razor component at runtime. Let's create a property of type iEnumerable that is strongly typed with the product category DTO type. Let's create a string property named errorMessage. Let's override the onInitialized async method. Let's create code within the onInitialized async method that retrieves a collection of objects of type product category DTO from the server and assigns the returned collection to the product category DTO's property. Great. Let's implement the code for the product categories nav menu Razor file. So we need to create a using directive that references the shoponline.web.pages namespace. So let's add the appropriate using directive to the _imports.razor file. We are adding this using directive because we are going to add appropriate tags to the product categories nav menu Razor file that reference relevant child Razor components that have been added to the pages directory. For example, the display spinner child Razor component. So notice that we are creating a LINQ that contains a category ID parameter. We'll later write code that uses this parameter value to query the server for a collection of product data that is related to a particular category denoted by the relevant category ID value. So we haven't yet written the code for the products by category Razor component. We'll write the code for this Razor component a bit later. This Razor component will contain code for displaying a collection of objects of type product DTO that are related to the category ID value that will be passed as a parameter to the products by category Razor component. So the next step is to reference our new Razor component from within the Razor component that contains the main menu that appears to the user in the sidebar of the UI. So let's add the appropriate tag to reference our product categories nav menu razor component. Let's run the code. And we can see that our product categories are now appearing as menu items within the sidebar. However, as you can see, the style of the product category menu items are different from the home menu item, because the code that produces the category menu item is contained within a different razor component. So to solve this, I'm simply going to copy the CSS code from the navmenu.razor.css file and paste it into a new CSS file that we must name product categories navmenu.razor.css. So this will result in the product category menu items being styled like the home menu item. So we are flagrantly violating the principle of dry, don't repeat yourself here. I'm doing this deliberately to keep up the momentum in creating the code for this application, so that I can effectively keep the focus on the aspects that are the subject of this part of the course. You can of course centralize the CSS code for the menu items in adherence with the principle of dry. However, for the reasons I've just explained, I won't address this issue in this part of the course. Great. So let's move on to create the code for filtering the products by category. Let's go back to the shoponline.api project. Let's go to the iProductRepository interface. Let's create a new method definition within the iProductRepository interface. The code that we'll implement for this method will be responsible for retrieving a collection of product data that is related to a particular product category. So let's implement the code for the method that we have just defined within the product repository class. Let's create an appropriate action method to expose this functionality to calling client code. Great. Right, let's go back to the shoponline.web project and implement the service-related code regarding the functionality for retrieving product data related to a particular category ID. Let's open the iProduct service interface and create an appropriate method definition. Let's implement the code logic for the method definition that we have just created. So here we are appropriately requesting a collection of objects of type product DTO that are related to a particular product category. Right, let's create a Razor component responsible for displaying the product data filtered by category on the UI. Let's name this Razor component products by category.razor. Let's create a class named products by category base. Let's implement the code for the products by category base class. Firstly, let's create a property that represents a parameter that will be passed into this Razor component. The value passed into this category ID parameter will be an appropriate category ID value. Note that we are able to declare that a property represents a parameter by decorating the relevant property with the parameter attribute. Let's create the other necessary properties for our Razor component. So, we want our collection of products to be retrieved for a particular category only when the category ID parameter is set. So we can do this by implementing our code within a method that is called by Blazor in response to a lifecycle event occurring when our parameter value is set. So to achieve this, we are overriding a built-in Blazor method named onParametersSetAsync. So let's write the code within the onParametersSetAsync method. Our code simply retrieves the appropriate products data from the server based on the value passed into our category ID parameter. let's write the appropriate UI code within the products-by-category.razor file. So let's first use the @page directive to appropriately declare the relevant root template information for our products-by-category razor component. Let's write code to inherit from the products-by-category base class. Let's implement the code logic. So as you can see, we can reuse our display products razor component that we created in a previous part of this course to display the relevant products data to the user. Let's run the code. Excellent. So you can see that our product category menu items appear differently when compared to the home menu item. So let's fix this in code so that our menu items are displayed in a consistent way to the user. Great. Let's finish off by adding an appropriate logo for our application. Excellent. I hope you have enjoyed this video. I look forward to presenting the final video in this series, where we'll optimize our code to potentially create better performance for our application. Hi and welcome. I'm Gavin Lon. This is the 11th and final part in a series of videos dedicated to building a shopping cart application using Blazor WebAssembly and Web API on .NET 6. So, we have now built our basic shopping cart application. But is software ever really 100% complete? At points, there may be bug fixes to make. We may need to upgrade our application with the latest technologies. A requirement may arise to improve the overall performance of the application. There may be parts of the application where UX, user experience, can be enhanced. In this video, we are going to look specifically at how we can improve the performance of our application by optimizing our code. There are two areas where we can potentially enhance the performance of our application. Item number one. In the Web API component, we are currently making two separate queries to the database when retrieving product data. Our code is returning both product data and product category data to the calling client. To do this, we are currently calling two separate methods in the product repository class. One for retrieving details about the products from the products database table, and the other for retrieving details about the product categories from the product categories database table. So in this video, to potentially enhance performance, we are going to retrieve the product and category details through one query to the database instead of two. The other area where we can improve performance is by using local storage within the Blazor component to store both the product data and shopping cart data, so that when our application needs to retrieve relevant product data or shopping cart data, our code can retrieve the relevant information from local storage, i.e. data stored on the client within the user's browser, as opposed to making a trip, as it were, to the server every time the relevant data needs to be retrieved. So basically, the travel time in retrieving the relevant data can be shortened in certain scenarios. The data can be retrieved on the client instead of the server. For content like this and much more, please consider subscribing, and please ring the bell so as to be notified of future content. If you like this video, please hit the like button, and please feel free to share this video with anyone you feel may benefit from its content. So let's attack the first item. Let's go to the shoponline.api project. Let's optimize the code on the server, where we can make one query to the database to retrieve both product information and related product category information, rather than use two separate queries for this purpose. So the first step is that we need to modify the class representing the product entity. So we must first add a public property to the product class that is of type product category. Let's add the foreign key attribute to our new product category property. We can then pass an appropriate string value to the foreign key attribute that is used for declaring which property in the product class must be used for joining the product entity to the product category entity. So this code will indicate to EF core, as it were, how we want to join the product entity to the product category entity. Let's go to the product repository class and first modify the getItem method to appropriately join the product entity to the product category entity in the relevant LINQ query. So to do this, we can use the include method like this. We are establishing the join between the two entities through this lambda expression. Notice the product category property that we recently created within the product class. For this query, we only want to retrieve one item, so we can use the single or default async method to filter the product data based on the relevant product ID passed to this method. Then for the getItems method, the code is similar to the getItem method. But for the getItems method, we wish to return all the products that are currently stored in the products database table with the related product category information to the calling code. So we of course don't need to filter the data, so that means we don't need to use a method like the single or default async method in this query. Then the last method that we need to appropriately modify is the getItemsByCategory method. If we open the ProductController class, we can see that we can now simplify the code here, but first we need to appropriately update the relevant extension methods responsible for converting objects of type product to objects of type product DTO. So let's first update the extension method that converts an individual product to type product DTO. Great. Then let's update the conversion extension method that converts a collection of objects of type product to a collection of objects of type product DTO. Great. We can now update the relevant action methods accordingly. We no longer need to query for the category items in a separate query that we are using here to get a collection of category items. So we've potentially improved performance of the server-side code through an appropriate code optimization exercise. We are only dealing with a small amount of data, so the performance improvement would probably be negligible. But if we were dealing with large amounts of data, the performance improvement would be more significant. So let's look at the second way that we can improve the performance of our application. The second way that we can improve the performance of our application involves an update to our Blazor component. So let's go to the shoponline.web project. Let's see how we can reduce the number of trips to the server we are currently making for retrieving relevant product and shopping cart data through the use of local storage. So we could use JavaScript and Blazor's JavaScript interoperability feature and write our own local storage functionality. It turns out, though, we don't need to go to this kind of trouble, because someone has already made available a NuGet package that contains the local storage functionality we need. So let's invoke the NuGet Package Manager window. Let's search for local storage. And this is the package we want to install. So let's install the blazor.localStorage NuGet package. For more details regarding local storage, please navigate to this URL. Basically, the JavaScript local storage object allows you to save key value pairs in the browser. Note, the local storage object stores data with no expiration date. The data is not deleted when the browser is closed and are available for future sessions. So the local storage functionality provided to us within the blazor.localStorage NuGet package abstracts the JavaScript code for managing local storage. So we don't need to write the relevant JavaScript code ourselves. We are now going to create two services to encapsulate our local storage functionality. So let's first create an interface named iManageProducts Local Storage Service. Let's create two method definitions, like this. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named removeCollection. Let's create an appropriate service class to implement the methods defined within the interface we have just created. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iProductService injected into our constructor at runtime. Note that the iLocalStorageService type is a type provided by the Blazor.localStorage NuGet package that we have now installed. So this type will be used to implement the necessary local storage functionality. Let's create a private method named addCollection. This method simply retrieves the product data from the server and saves the relevant product data in the user's browser using local storage. Okay, let's create a string constant to store the key that will be used to identify the relevant value. In this case, the relevant value is a serialized collection of objects of type ProductDTO. Let's implement the code for the getCollection method. So this method first tries to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, we can call the addCollection private method to retrieve the relevant data from the server and save the relevant data to the user's browser using local storage. The removeCollection method simply removes the relevant data stored within the user's browser using local storage. Right, let's create an interface within the contracts folder named iManageCartItems Local Storage Service. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named saveCollection. Let's create an appropriate method definition for a method named removeCollection. Right, let's implement the relevant code for the interface that we have just created. So let's first create a class named ManageCartItems Local Storage Service. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iShoppingCartService injected into our constructor at runtime. Let's create a constant to store the key that will be used to identify the relevant item stored using local storage. The local storage item in this case will be a serialized collection of cart item DTO objects. Let's create a private method named addCollection. This method simply retrieves relevant data from the server and appropriately saves the data to local storage. This method attempts to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, the code retrieves the relevant data from the server and appropriately saves the relevant data to local storage. Let's implement the code for the removeCollection method, which involves appropriately deleting a collection of objects of type CartItemDTO from local storage. Notice that the key constant is used to identify the relevant local storage item. Let's implement the code for the SaveCollection method, which involves appropriately saving a collection of objects of type CartItemDTO to local storage. So we haven't yet registered the iLocalStorage service type provided in the Blazor.localStorage package with the dependency injection system. So let's open our program.cs file and apply the code to register the iLocalStorage service type for dependency injection. So we can use the add Blazor local storage extension method for this purpose. We must then also register our two new service classes that we have created to abstract the relevant local storage functionality with the dependency injection system. So let's now implement the relevant local storage functionality within the relevant Razor components in order to hopefully increase the performance of our Blazor component. Let's open the product's base class. This is the base class for the Razor component that first loads when our application is first launched. Let's create the code to ensure that our two local storage services are injected into this Razor component. Let's say that when the product's Razor component is loaded, we want to clear the relevant local storage items from local storage. This will force our code to retrieve the relevant data from the server at this stage. Then subsequently, we want the relevant data retrieved from local storage to enhance performance. So let's create a private method named clearLocalStorage and use the relevant functionality we have created within the relevant services to remove the relevant data from local storage. Let's call this method from within the onInitialized async method. Then instead of going straight to the server for our data, let's use the appropriate local storage service object to first check to see if the relevant data resides within local storage. Of course, in this case, we are clearing the data before this method is called, which will force our code to retrieve the data from the server. However, our code will subsequently save the data retrieved from the server to local storage, which means that when other Razor components retrieve the relevant data, the data will be retrieved from local storage on the client side, which means an unnecessary trip to the server will be avoided. So this gives us an idea of how we are able to increase performance of our application using local storage. We can also use our Manage Cart Items Local Storage Service object to retrieve any cart item data that may be saved to the user's shopping cart, like this. So in this case, this code will retrieve the relevant data from the server and save the data to local storage. Any data retrieval of items within the user's shopping cart can then be done from local storage, and therefore trips to the server are saved and the performance of our application is potentially enhanced. Let's appropriately update the shopping cart Razor component. Let's write the code so that an object of type iManageCartItems local storage service is injected into this Razor component at runtime. In the onInitialized async method, let's replace the code that retrieves the relevant cart item data from the server to get the relevant data from local storage. When a user updates the quantity of a particular item saved within the user's shopping cart, we must update the relevant local storage item. This is because, of course, the relevant shopping cart has now changed. We can appropriately implement the save collection method for this purpose. We must also use the appropriate local storage service to implement the code to update the relevant local storage item when a user removes an item from the user's shopping cart. Let's implement the relevant local storage related code for the product details Razor component. So this component is responsible for displaying details for a particular product. This Razor component also contains functionality for adding a product to the user's shopping cart. Let's first create a private property to reference the shopping cart items collection here, because when the user adds a product to the user's shopping cart, we want our code to update the relevant local storage item. We no longer only want the code to update the relevant shopping cart on the server. We need to keep the client-side local storage data up to date as well. So let's first write code to update our shopping cart items private property with data retrieved from local storage within the onInitialized async method. So within the method responsible for adding a new item to the user's shopping cart, we need to write code that not only updates the data on the server, but also updates the relevant local storage item. So we can implement the desired functionality in code like this. We can also now implement code that gets data for an individual product from local storage Great. Let's appropriately update the Products by Category Razor component to include local storage functionality. Let's write code so that an object of type iManageProducts local storage service will be injected into this Razor component at runtime. Let's write a private method so that the products filtered by category ID are retrieved from local storage. Let's appropriately call our new private method from within the onParameters set async method. Lastly, let's appropriately update the checkout Razor component with our local storage functionality. Great. Let's run the code. Excellent. That definitely seems to have made a positive difference to the performance of our shopping cart application. If you've made it to the end of this course, well done! You have learned quite a lot about Blazor WebAssembly and Web API. We have also learned how to create a basic SPA application where the vast majority of the code is implemented using C#. I hope you have enjoyed going through this course as much as I enjoyed creating it. For content like this and much more, please consider subscribing and please ring the bell so as to be notified of future content. If you liked this video, please hit the like button and please feel free to share this video with anyone you feel may benefit from its content. I really enjoy engaging with you in the comments section, so please feel free to leave a comment. The latest code can be found on GitHub. A link to the relevant repository has been included below in the description. Thank you and take care.